Hello students, this is your friend Sumit and today we are going to start topic 7 of this series, that is work, energy and power. Work, energy and power is one of the easiest chapter and the fundamental chapter. Okay, if you ask me what all subtopics are asked from here, you'll get questions from work done, you'll get questions from concept of the potential energy, the conservation of mechanical energy, the vertical circular motion and the collisions part. But the thing is, these questions are going to be very easy, very simple, provided you have the conceptual clarity. So in this class I'm going to provide you the conceptual clarity. I'm going to discuss all the concepts in great detail, with showing you what varieties of questions are asked by NTA till now and how to tackle them in a very easy and simple way. With that, you need a set of questions for practice as well. So I have a good collection of questions for you. You'll get that collection of questions and the notes from the link that is given in the description box. So if you go in the description box, click the link, you'll go to our app, that is PW app. So many students are taking advantage of the PW app and getting very good ranks. So from there you'll join the free batch and you can access the notes as well as the practice sheets. If you ask me what is the weightage of this chapter, so I'll say we can expect up to one question from this particular topic, but that one question is going to be very simple and very easy. Okay, so don't miss that. So let us begin the discussion. Also, after watching this video completely, make sure you comment completed in the comment box. Let us start the discussion. So let us begin our discussion. We'll be covering all the topics in great detail. First of all, we'll talk about the dot product. We call dot product as the scalar product also. Like vectors has two types of product, the scalar product and the vector product. So vector product we denote with A cross B, dot product we denote with A dot B. Okay, we will talk about that. Then we will talk about work done, the work energy theorem, then concept of potential energy, the vertical circular motion, and finally the collisions. Okay, so all these things we will be covering in detail. So first of all, let us talk about the dot product. So let us take two vectors A and B are there. Okay, so A dot B, this we say as the dot product of vectors A and B. Okay, so this is the dot product, or we call that as a scalar product. Scalar product of A and B. Now what is basically A dot B? A dot B is AB cos of theta. So here if we have, let us take vector A and vector B, the angle between them is theta. So A dot B is AB cos theta, means magnitude of A into magnitude of B into cos of the angle between A and B. Okay, so this is how we find the dot product. Or let us take, if A is given in form of I cap, J cap, K cap and B is given in form of I cap, J cap, K cap format, then how we write that? So if let us take A is AX I cap plus AY J cap. AX means the component of vector A along x-axis. AY means the component of A along y-axis. This is not A into x. So you may get confused. This is not A into x. This is AX. Okay. I cap plus AY J cap plus AZ K cap. Let us take, this is how A is given to us, and B is given to us as B is equals to BX I cap plus by j cap plus bz k cap. Okay, so this is how two vectors are given to us. Then how we write A dot B? So A dot B is, now we multiply this, like there is a dot in between and we multiply this. If I multiply AX I cap with BY J cap, let us take, that will be 0. Why so? Because angle between these two is 90 degree. Cos of 90 is 0. Therefore, AX into BX, it will be AX into Bx, the multiplication of Ax, By, this will be 0 because the dot product of that will be 0, and similarly the scalar multiplication of Ax into Bz will also be 0 because here also I cap and J cap has 90-degree angle. Okay, so we'll get only Ax, Bx. Similarly for y, if I write, we will get Ay, By plus Az, Bz. Okay, so x component magnitude is multiplied with the other x component magnitude plus a by by plus az bz. This is a vector. Here it's not I cap j cap. So sometimes students what they write here also they write. No, this is now a scalar ax bx plus a by by plus az bz. Okay. Now let us take, if you have to find angle between two vectors, then how you can find? I can write from here. If I need to write that, how to find angle? So from here I can write cos theta is equal to a dot b divided by ab, the dot product divided by magnitude of a into magnitude of b. This is how we can find the angle between the two vectors. Or let us take, I have to find component of one vector along another vector. Now let us find component of b here along a. So what I'll do, this is the component of b along a, this much. Okay, if I take the projection on a, so what is that? This is b cos theta. Okay, so the length is b cos theta and the direction is a, direction is along a. So how will I write? So I say this to be b cos theta into a cap. A cap means the unit vector along a. Okay, how I can write b cos theta? I can write b cos theta as a dot b divided by a. B cos theta as a dot b. A dot b will be ab cos theta. I need only b cos theta, so divide by a into a cap. Okay. Now a cap I can write either as a vector divided by a magnitude of a, or I can leave it as it is a cap also. Okay, so I can write it as a dot b, a cap as a vector divided by magnitude of a. So a vector divided by magnitude of a, so this will become a square. So this is what? This I'll say this is component of b along a. This is how we can use. Okay, so this is the fundamental of dot product. If two vectors are perpendicular to each other, their dot product is 0. So this is also condition. Sometimes it is mentioned like two vectors are given, find the conditions as that they are perpendicular to each other. So what we will do, we'll make their dot product to be 0, because AB cos theta, if theta is 90, this will be 0, cos 90 is 0. Okay, so two perpendicular vectors are there, their dot product will be 0. And what else can be asked from here? Like the magnitudes are given, the angle are given, then the dot product, or the components are given, then the dot product, or the, I can say, angle is asked between the two vectors, or the component of one vector along another vector, or the condition to be for two vectors to be perpendicular. These type of things can be asked. So there you need to understand that we need to use dot product concept. Okay. Now let us talk about work done. How work done is defined. So in physics, work done is defined as W, that is integration of F dot dr. Let us take the force F is acting on the particle, and the particle is moving from initial position R1 to final position R2. Okay, so a particle was there. Let us take this. Force is acting F, and it moves somewhat like this. And here if I say the initial position was R1 and the final position is R2, and then you need to find the work done by the force. This is my x and y. Then we say the work done is defined as F dot dr from R1 to R2. Now, if the particle is moving along one axis, let us take along x-axis, then we write along x-axis. Then how we will write? We will say that as, let us take another color. So that is, I will say W is equals to integration of F dot dx from initial position x1 to final position x2. And here also the condition can be f is variable, f is constant. If f is constant, we can take that out. Integration of dx will be there, okay, and integration of dx will be x from initial x1 to final x2. That will become our displacement, okay. And here also, if f is constant, we can write that way also. Let us write that thing also. If f is constant, if f is constant, we write our work done W as f is constant, taking that out, f dot integration of dr from R1 to R2, and this becomes f dot R2 minus R1, which is my displacement. So this I write as f dot s, or I can say this is f s cos theta. Now, like if I ask what is work done from students, so generally what the answer is, that is force into displacement. No, that is incorrect. Force into displacement is only for that condition when force is constant and my cos theta is equals to 1. Then only it will become force into displacement. One thing is, it is f dot s, and f dot s is also for the condition when f is constant. If force is variable, you cannot use that formula. Then you need to integrate it. Okay, keep this thing in mind. Now, when the work done will be 0, what is the condition for work done to be 0? Now, work done can be 0 either when force is 0, or when displacement is 0, or when the angle between force and displacement is 90 degree. Any of the condition can be there, okay. So if, let us take, I say W is 0, so what can be the condition? First is my force is 0, second condition my displacement is 0, or the third condition that theta is equals to 90 degree. The angle between force and displacement, that is equal to 90 degree. Getting this thing? So you should remember the general formula, that is this, that work done is equals to integration of f dot dr from R1 to R2, from initial position to final position, or along 1D you want to remember f dot dx, okay. And for constant force, this, or you can say this, the same thing. When the force is constant, then only you can use this expression. Now, what is the unit of work done? What is unit of force? That is Newton. Unit of r, dr, distance you can say, and Newton into the distance, that is meter. So Newton meter, what is that? That is energy. So unit of work done is same as the unit of energy, and we know that as joule, okay. So if I talk about the SI unit, that is joule or Newton meter. Or if I have to write dimensions, can you tell the dimensions? What is the dimension of joule? Joule is Newton meter, Newton is kg meter per second square into meter. So kg meter square per second square. So this will become kg meter square per second square. Okay. So basically, when we are doing work on an object, so what we are doing, there is basically a transfer of energy. We are giving some energy to it, or if I am doing negative work, so it means we are taking some energy from that. That is the, I can say, the understanding in work done. Okay, so we will come to work energy theorem also in a while. First, before that, let us discuss about some of the questions we have for work done where the force is constant. Let us take this question. A small particle moves in position. Now this is my initial position R1, okay, from initial position to this position, okay, to position. This is my final position. This is my R2, the final position. And initial position is this. This is my initial position R1. Under the action of a force, and this is my force. So what we need to do? Force is constant or not? Force is constant. Which formula? F dot ds. So whenever you have to find work done, make sure you check first whether the force is constant or not. If the force is not constant, don't use F dot s. Then use integration of F dot dr. Keep this thing in clear. Okay, keep this thing clear in your mind. Many times what happens, students see that, okay, this is the expression for the force. Okay, do F dot s, get the answer. But the force was not constant there. Force was variable. Your answer will be incorrect. Okay, so make sure use F dot s only when force is constant. Here I checked, yes, this force is constant, not changing. So I can say that work done is F dot s. Also, work done is a scalar quantity because it is a dot product there between two vectors. So dot product of two vectors gives us scalar because that is a scalar product. Okay, so work done is a scalar quantity. There is no direction for work done. So now using this expression, what is F? F is 5 I cap plus 2 j cap plus 7 k cap dot. Displacement. Displacement is final position minus initial position. This is my final position. So from I cap, I'll subtract this I cap. From this j cap, I'll subtract this j cap. From this k cap, I'll subtract this k cap. This is how we subtract two vectors. Okay. So this is x2 minus x1. So x2 minus x1 will become 5 minus 2, that is 3. So 3 I cap. y2 minus y1. So minus 2 minus 3 minus 5 j cap. This is 1 minus minus 4. This is z2 minus z1. Okay, what is that? Plus 5 k cap. Z2, that is 1, minus z1, that is minus 4. So that will become plus 5. Now dot product. So how we take dot product? Multiply this x with this. So this is 5 into 3, 15. 2 into minus 5 minus 10. 7 into 5, 35. Getting it? Okay, so what it is now? This is 35 and this is 5. So we got 40 joules. Work done is 40 joules. 40. Simple, straightforward questions. And these questions are asked in mains. You see, this was asked in 2023, shift 1. Okay. Another question. A block of mass 1 kg is pushed up a surface, okay, inclined to horizontal at an angle of 60 degree, where force is given to us as 10 Newton, parallel to the inclined surface. What is, when the block is pushed up by 10 meter along inclined surface, the work done against frictional forces. So work done against frictional force means, basically that is, he is asking the magnitude of work friction is doing. Like friction is doing, let us take minus 10 joule work. So you are doing how much work against friction? 10 joule. Okay, if friction is doing minus 10 joule work, you are doing how much work against friction? 10 joule. Getting it? Yes. So we need to find here work done by friction. Now I am again asking you whether the frictional force here is constant or variable. Constant, because the block is moving. Friction is kinetic. Kinetic friction is constant. Friction force is constant. So to find the work done by friction, what we can use? F dot s. Okay, so let us write that work done by friction is equals to my friction force dot the displacement. Now how much is the frictional force? This is moving, okay, in the upward direction. What will be the normal reaction on an inclined plane? Mg cos theta. How? You see, mg force is in this direction. If I take the component of mg in this direction, that is mg cos 60, cos theta, theta is 60, okay. in this direction, the normal reaction is there. So the block is not moving in this direction perpendicular to the incline. So I'll say N is equals to mg cos theta. This is my normal reaction. Okay, now friction is mu into N because that is kinetic. So if I say frictional force, so that we will say that is mu into N. So mu mg cos theta or cos 60 here. Now let us put what is mu. What is mu? Mu is okay 0.1. What is m? M is 1. What is g? G is 10. So 0.1 into 1 into 10, that becomes 1. Yeah. And cos of 60. Cos of 60 is 1 by 2. So this becomes 0.5 Newton. Everything is clear? 0.5 Newton we got. Now friction force is in which direction? Of course, that is in this direction. Because block is moving like this, kinetic friction is opposite to the direction of motion, friction is in this direction. What is the direction of displacement? Displacement is in this direction. And how much is the displacement? Displacement is 10 meter in this direction. What is the angle between the friction force and displacement here? Can you tell me? Displacement is in this direction, friction is in this direction, angle is 180 degree, isn't it? Because that is opposite. So I'll say this is basically Fs cos 180. What is F? F is 0.5. What is S? S is 10. What is cos 180? Minus 1. So how much is this? Minus 5. Minus 5 joules. Friction is doing minus 5 joule work. How much work we need to do against friction? 5 joule. Friction is doing minus 5 joule. We did 5 joule work against friction, and this is what he is asking here. Okay. Now, here one more thing I needed to discuss, that what is that? Just a minute. Now we discussed that work done is equals to integration of F dot dr. If I ask you what integration gives us, what will be your answer? Integration gives us area under the curve. Integration gives us area under the curve. So let us take, you are having the force displacement curve. This is my force displacement, or you can say force position. Okay, and let us take this as my position, and the curve goes like somewhat like this, then this, okay, and then maybe this, and then like this. And now I ask you, how much is the work done by the force? So what you will say? We know that work done is equal to integration of F dot dr. Okay, so this will give you the area under the curve. Okay, this is my force position curve. So how much is this area? We'll find this area. Okay, and here the area is negative. I need to consider this area as well, and this area will be negative. Why negative? Because the force is negative there. Displacement is positive, force is negative. Here the angle between force and displacement is 180. So this work done will be negative. So this area will consider negative. Okay, so this area is, let us take A1 in magnitude, and this area is my A2. So I'll say here work done will be A1 minus A2, total work done. If the force is only positive, the total area is positive, just find the area. Okay, so sometimes what happens in questions, the force displacement curve is given, or not directly the curve, they may be telling like the force is varying with displacement like this. So sometimes it is easier for us to draw the force displacement curve and from there write the work done. Let us see that question. This question. So here what is happening? A person pushes a block on rough horizontal platform surface he applies a force of 200 Newton over a distance of 15 meter. Thereafter, he gets progressively tired and applied force reduces linearly with distance to 100 Newton. Now, how to find this work? Now, either you write the variation of this force, okay, it is varying linearly with distance, so you can write the equation also, okay. From there, you will integrate and you will find, that is one way, or better way is simply draw the force displacement curve and from there you can write. Let us draw that. Initially, the force was 200 Newton over a distance of 15 meter. Okay. Over a distance of 15 meter. So this is my 15 meter and this is 200. Now, next thing. Thereafter, he gets progressively tired and his applied force reduces linearly with distance to 100 Newton. He gets tired and now the force reduces linearly to 100 Newton. Means the force goes like this. Linearly means straight line, isn't it? Linearly means straight line. So straight line like this until 100 Newton. This is 100 Newton here. Okay, now the total distance through which the box has been moved is 30 meter. 15 was here, total is 30. Okay, it means this is also 15. This is 15. Now, what is the work done by the person during the movement, total movement of the box? Okay, now it is very simple. We draw the force displacement curve. Now just find the area under this. So first we are having this rectangle. This side you can say how much? 15. This side is 200. So this area is 15 into 200. Let us write that 15 into 200. Now, we have a trapezium. What is the formula of area for trapezium? You remember that? 1 by 2 into sum of the parallel sides into the distance, perpendicular separation between the parallel sides. Or you can divide this into one triangle, another rectangle. That way also you can find for triangle 1 by 2 into base into height plus rectangle base into height. Okay. So, I am using trapezium formula. So, for this, what is that? 1 by 2 into sum of the parallel sides. This is 200 plus 100, that is 300 into the distance between them, that is 15. So what it is? This is 150. 150 into 15. Yeah. And everything is fine? Yes. And this is 15 into 200. I need to add the two areas. So what I'll do? I'll take 15 common. 200 plus 150, that is 350. So 15 into 350. How much is that? So 0, 5, 7, 45 and 7, 52. So that is 5250. Yeah, 5250 joules. Now if you try to write the equation of this straight line and then integrate to find the work done, it will take you time. Because graphically finding the area is easier, okay, as compared to writing the equation in itself will take you time. Okay, writing the equation for this straight line will take you time, and then integrate will take few more steps. So it will take you more than, I'll say 3 minutes in this question. But if you draw this curve, it will take hardly 1 minute. Now another question. Arrange 4 graphs in descending order of total work done, where W1, W2, W3 and W4 are work done corresponding to A, B, C and D respectively. Now we have to see which one is greater, okay, arrange them like this. So here we need to see which area is greater, which area is lesser. Upper area is positive, lower area is negative. Now you see, easier thing. Let us compare A and B. In A, positive area is this, negative is this. In B, positive negative is same because this is x naught, this is x1, x naught, x1. Positive negative is same. Here positive is added. So I'll say work done by B, that is my W2, is greater than W1. That thing is clear to me. Let me write it above here. So W2 is greater than W1. This I got. Now see this graph C. Work done by B, that is still here. Now you are adding another positive area. It means W3 will be greater than W2. Okay, W3 will be greater than W2 because we added another positive area. Now D option. Okay. In D, if we talk about there is negative area. Okay. And this negative area, how much is that? If you see here, this positive, this negative, this was same, that is same here. Okay. Now you are adding this negative area, this much, that is you can say x2 minus x1 into f, and then there is another positive area that you are adding, but negative added is greater. So we will say that WD or W4 is lesser than W1. You see, compare this one and this one. Here negative area is more added, therefore I will say W4 is lesser. So which option? W3, W2, W1, W4. 3, 2, 1, 4. First option is there. Okay. Yeah. Here this x and this x, the difference between x0 and x1 is same as x2 and x1, and it is further, yeah, that is same. Therefore we are considering that negative area that we are adding, that is more than the positive area that we are adding. Therefore this will be negative as compared to this, means lesser as compared to A. Therefore I am saying W4 is less than W1. Okay. So these were few questions based on the graphs. There may be other varieties. Here you may say a general force displacement curve is given to you, and then they are asking the magnitude. They may ask you the work done between x is equals to 2 to x is equals to 5, let us say. Then you need to consider only the area between x is equals to 2 to 5. Don't take the area, entire area there from 0 to, let us take 10. No, don't take the entire area. Between the limits only you need to consider the area. Let us read this question. A block of mass m is kept on platform which starts from rest with constant acceleration g by 2, okay, upward as shown. Work done by normal reaction on block in time t is. It is moving up. Normal reaction is acting in which direction? Upward. Okay. Displacement is in which direction? Upward. Is the normal reaction constant or not? Constant. It's not changing, isn't it? The acceleration is constant, normal reaction is constant. Normal reaction is not changing, it means that is a constant force. I can use the formula for constant force. What is the formula? Work done is equals to F, sorry, here not vector, this is W. Work done is scalar, F dot S. Now, what is basically normal reaction? How much the normal reaction is here? Let us draw the free body diagram of this mass, then we can find the normal reaction. Okay. So for this mass, mg is acting in the downward direction. Normal reaction is acting in the upward direction. It is having an acceleration g by 2 in the upward direction. Now I can say n minus mg is equals to m into a. N minus mg is equals to m into a. Hope you have seen the video on laws of motion, so you are clear with this, how I am writing this equation. I am considering upward as positive, okay, therefore I wrote it like this. So from here I can say n is equals to 3 mg by 2. Got the normal reaction. How much is the displacement in time t? Moving with a constant acceleration, and it starts from rest. So displacement will be s is equals to ut plus half at square. U is 0, displacement s is half a is g by 2 t square. So this will become gt square by 4. So this displacement I got. How much is the angle between force and displacement? Both are in the upward direction, angle is 0 degree. So I'll say this is basically my F as cos 0. What is F? 3 mg by 2. What is S? gt square by 4. Cos 0 is 1. So what it is now? 3 by 8 mg square t square. Such simple questions, straightforward questions are asked in mains, where there is hardly any mistake you can make here. Is there anything you can do mistake here? No. Very simple, straightforward. Therefore, I am saying make sure your concepts are very clear. You are not confused. If your concepts are very clear, any question from anywhere you can crack very easily. Work done by variable force. Now, the general formula, work done is equals to integration of F dot dr. It goes from R1 to R2, or along 1D if I say, let us take the force and displacement are only in 1D. So along one dimensional motion if I write, so it will be integration of F dot dx, okay, x1 to x2. There don't take F outside. Why so? F is constant. F is variable, sorry. When F is constant, then only you can take. Here force is variable. Now when I am saying work done is equals to area under the curve, it applies for constant force only or variable force also? Variable force also, because integration of F dot dr is anyways the area, whether the force is constant or variable. Previously we discussed that there the force was variable. Okay, there the force was variable. We were able to find that by area. So if curve is given to you, just find the area. That is the work done. Whether the force is variable or force is constant, that is equal to the area of the curve. But if let us take equation is given to you and there you see some variables, whether the force is varying with time or whether the force is varying with your position, like these parameters will only be there. Okay, if it is varying with that, it means the force is not constant. Force is not constant, use integration, don't use f dot s. Okay, let us come to questions. A force F, that is 2 plus 3x I cap, acts on a particle in direction in the x direction, where F is in Newton, okay, is in Newton and x is in meters. Okay, this was here x in meters. The work done, okay, the work done by the force during the displacement from x is equals to 0 to 4. One thing is very clear, here x is coming, force is not constant, that is variable. If force is variable, I'll use the work done formula as integration of F dot, this is along one direction, so F dot x, so that will become 2 plus 3x dx, and x goes from 0 to 4. Now integration of 2 will become 2x, 3x integration will become 3 constant out, x integration x square by 2, limit from 0 to 4. So this will become 2 into 4 minus 0, putting the limits. So 2 into 4 plus 3 by 2 into 4 square is 16. Like this, yeah. So this is 8 here. So this is 24 plus 8. How much is that? 32 joules. Is this clear? 2x plus 3x square by 2, checking if there is some error or not. 3 by 2 into x square, that is 16. Okay, 24 plus 8, that is 32 joules. Easy questions. Another question. Now, this is a bit different question. Here you need to understand a concept. Okay, consider a force F is given as, now here this is not along one direction, this is a 2D force, xi cap, yj cap. The work done when it goes from 1, 0 to 0, 1 along the line segment, along this line segment. Now, here how we can write this? So, here my R, you will say the force is not along one direction, also it is variable. in such particular cases, what you need to do, you can write your dr as dx I cap dy j cap dz k cap. Write r dr like this. Your f was given as fx dx, fy dy, fz dz. Wait a minute. Fx I cap. Oh, after dot product I wrote it. This was given as fx I cap plus fy j cap plus fz k cap. Okay. This is your f. Now when you take the dot product, so this will become fx dx plus fy dy plus fz dz. Integrate it separately. Put the limits. X goes from my x1 to x2, y goes from my y1 to y2, z goes from my z1 to z2. Okay, and this will become my work done. Okay, when force is given in terms of I cap, j cap, k cap, and there may be some variables x, y, z like that. Okay, and the displacement thing is given to you, then you can integrate to find. Now coming to the question here I am having only x and y. So when I write f dot dx, so it will become that is minus x I cap plus y j cap. This is my f dot dr. Dr is dx I cap plus dy j cap. Need not write k cap. Okay, this is my dw, and then it will become minus x dx plus y dy integrated. This is my work done, and x goes from 1 to 0. X goes from, this is going from a to b, so x goes from 1 to 0. So x goes from 1 to 0, and y goes from 0 to 1. Y goes from 0 to 1. Now write it. This is minus of x integration is x square by 2. This is 1 to 0 plus y square by 2 from 0 to 1, and this is minus. Now when you put the limits, upper 0 minus lower 1, so 0 minus 1, minus 1 will come here, so minus 1 by 2 plus here you will get 1 by 2, and this becomes 1 joule. That is option D. Okay, is this clear? Okay, now kinetic energy. So kinetic energy, we know if a particle is there, its mass is m, it's moving with velocity v, we say kinetic energy is half mv square. So particle of mass m moving with velocity v in some particular direction, so we will say its kinetic energy is half mv square. Kinetic energy is a scalar quantity, it's not a vector, and here we say m is my mass, v is my velocity. So if I try to find the unit, this is kg meter per second square. So kg meter square per second square, that is energy, isn't it? By the way, I am saying this is kinetic energy, so it is understood. If it is energy, it will have a unit of energy. So the unit of this is joule. And if I ask you the dimensions, same as that of the energy, ml2 t minus 2. Let us relate kinetic energy and momentum. We know momentum p, this is equals to mass into velocity. So if I talk about the magnitude, just mass into velocity. Now let us write here, this is half, multiply and divide with m, so mv whole square divided by m. What is mv whole square? This is p square. So this becomes p square by 2m. So kinetic energy is related with momentum of a particle as this p square by 2m. This formula is important. Questions are asked from the relation of kinetic energy and momentum. Kinetic energy you already know, but this relation keep in mind. Sometimes questions are asked like the momentum is getting this much times, how much the kinetic energy will change? Or let us take some questions like two particles are there, their momentum are related like this, find the relation between the kinetic energy, or the relation of the kinetic energy is given, find the relation between the momentum. These type of very simple questions are asked in 2024, 2025, we have seen such questions. Now we are having this question 2024. Okay, let us read. Two bodies of mass 4 gram, 25 gram are moving with equal kinetic energies. The ratio of magnitude of their linear momentum is. Kinetic energy is equal. It means K1 is equals to K2. What is K1? I can write P square by 2m. P1 square, K1 as P1 square by 2m1. So P1 square by 2m1. And what is K2? That is P2 square by 2m2. Now it is mentioned that the kinetic energy is, kinetic energy is equal. We need to find the ratio of magnitude of linear momentum. Means I want to find P1 by P2. So if I say P1 by P2, so P1 by P2 is m1 by m2 whole root. What is m1? m1 is 4 and m2 is 25. So 4 by 25 root is 2 by 5. Like for such questions, just by looking at the question, you can solve this question. Just by looking at the question. Need not even write things. Such straightforward questions are there in mains and these questions are asked. That is the point. Therefore, I am saying like you need to understand which are the things that are very straightforward and asked in mains. Now in work energy power, let us take in 2D collisions I am talking about. Okay, so in 2D collisions you may see, sir, here we need to write equations along these two perpendicular directions, and like that it may be like you may feel like it is a bit complicated for me to understand, but that may be difficult for you. This is very straightforward for you. At least you should understand this. If this is asked, you'll for sure do this. Okay, I'll explain that part also. So when kinetic energy of a body becomes 36 times of its original value, the percentage change in the momentum of the body will be. So kinetic energy is getting 36 times. It means K dash is 36 times of K. What is kinetic energy? Half mv square. It means velocity is getting 6 times of initial velocity. It means my momentum, or directly also root of that, so I can say. So my momentum is getting how much times? 6 times of initial momentum. So what is the increase, percentage increase? Momentum is 6 times of the initial. How much increase? 5p is the increased value. How much percentage is increased? 500%. Now after writing this, somebody may mark B option, but he is saying percentage change. Here it was saying it becomes 36 times. There was not change. Here it is change. Work energy theorem. So basically work energy theorem says that, let us take multiple forces are acting on a body. F1, F2, F3, F4. The sum of all the work done by all these forces is equal to the change in kinetic energy of the body. Okay. Let us write it. So when I say work done, I'll say my integration of resultant force dot dr. This is how I'll say work done to be integration of my resultant. F is my total force. Okay, dot dr. What is F? F is mass into acceleration. M into A dot dr. What is acceleration? Acceleration I can write as dv by dt or v dv by dr. Acceleration I can write as dv by dt or v dV by dr. Write it there. So I'll say this is m into v dV by dr, and here we are having dr integration. So dr and this, okay, got cancelled. So we got mv dot dv integration, and this will become, m is constant, integration of v with respect to v is v square by 2. So this will become m v square by 2. Limits, my velocity changes from initial velocity v1 to final velocity v2. So what it will become? Half m v2 square minus v1 square. What is this? This is half m v2 square is final kinetic energy, half m v1 square is initial kinetic energy. So this is work energy theorem. Okay, this is my work energy theorem, that work done by all the forces is coming out to be the change in kinetic energy, or sometimes we write this as directly delta K. Okay, if 2-3 forces are acting and you need to find work done by one of the force, then what you need to do? Then you need to integrate to find the work done. But if you want to find the total work done by all the forces, and let us take initial kinetic energy, final kinetic energy is given to, subtract that, the change in kinetic energy is equal to the work done by all the forces that are acting. Is this point clear? Make sure you comment. This class is not live anyways, but yes, you can let me know your thoughts, whether you are getting, if you have, let us take a conceptual doubt in any of the points, so you can ask those things in comments, so we will respond to that. Now another let us discuss question on this. To maintain a speed of 80 km per hour, a bus of mass 500 kg on a plain rough road for 4 km distance, the work done by the engine of the bus will be. How many forces are acting? One is, you can say, engine is doing work. Another is like friction is doing some work. Okay. So here we will say that the change in kinetic energy is 0, because he is saying that how much work need to be done to maintain the speed of 80 km per hour is maintained. 80 km per hour is maintained. 80, that is not changing. It means change in kinetic energy is 0. Change in kinetic energy is 0. Change in kinetic energy is 0. It means my total work done is 0. Work done by friction plus work done by, here you can say, what he was asking, the work done by the engine of the bus. Okay, this is work done by the engine. This is equal to 0. So from here I can say work done by engine is basically equals to minus of work done by the friction. So what is work done by friction? The friction force is constant or variable here? Friction force. Friction is kinetic, friction force is constant. Yes, constant force. So when I write work done by friction, I'll say this is just dot product of F dot S. What is friction force? It is moving on a horizontal surface. So I'll say that is mu mg into the displacement S into cos, angle between the displacement and the force of friction is 180 degree, because friction force is in the opposite direction, cos 180. Now put the values. Okay, minus. Okay, I'll put the values. First of all, let us put cos 180 as -1. So this is minus mu mgs. So put it here. Minus of minus, it will become plus. So plus mu mgs. So work done by the engine will be this much. So what is mu? Mu is 0.04, coefficient of kinetic friction, 0.04 into, what is m? Mass is 500 kg. G is not given, so we'll consider that as 9.8 into, what is S? S is 4 kilometer, okay, 4 into 1000, and we need to answer in kilojoules. So I'll say into 4, and this is my answer in kilojoules. Now these two zeros, okay, you can cancel these decimal places, okay. So what it is from here, this is 20 into this is 80. Is everything fine? Mu was 0.04, yes. M was 500, yes. G was 9.8, and kilometer, so 4 into 1000, which I converted to kilojoules, so I took 1000 there. Yes, everything is fine here. So now I'll get this as 98 into 5 into 2, okay, 5 into 2, and this 4 into 2 is 8. How much is this? 800 minus 16, that is 784. 8 into 100 is 800, okay, minus 8 into 2, 16, so that is 784. Perfect, okay. 784 joules, kilojoules, sorry. Now you may say, can we like engine force is like not given here, whether that is constant or whether that is variable, or the relation of that with the displacement and all these things, that is not mentioned. Yes, that is not mentioned. Just apply work energy theorem. Change in kinetic energy is 0. So work done by all the forces, whether they are variable or constant, is equals to 0. Now friction force, work done was very easy to find. I used that, got the work done by the engine from there. Another question. Here we are having a body of mass 0.5 kg travels on straight line path, velocity that is 3x square plus 4. The net work done by the force during its displacement from 0 to 2 meter is. Now this is variable or constant? Force is variable or constant? We may differentiate. Here we can see the acceleration, and from there we can say the force is variable. Okay, but that is not needed, because here we need to find the net work done. I can just see the initial speed and the final speeds. From there I can find the change in the kinetic energy, and that is my work done. Need not do integration and all those things. He is asking total work done. I will say total work done is equals to change in kinetic energy. That is half m v final square minus v initial square. What is v initial? Initially x was 0, so v initial is 4. From here if you put x is equals to 0, it is 4. What is v final? X is 2. So put x is equals to 2. This is 3 into 8, 24 plus 4, 28. Now put the values. Half m is 1 by 2 v final square, that is 28 square, minus v initial square, that is 4 square. Okay, let us take 4 square as common from here. 4 square will come, so that is 16. 1 4 will get cancelled, 4 will remain here, into this is 7 square, 49 minus 1, that is 48. 48 into 4, that is 192. 200 minus 8. See, you need not find the value of acceleration from there, expression for acceleration. From there you can find the expression for force, and from there you can do integration and all those things to find the work done. That's not needed here. Just see, the velocity is given, you can find initial final, change in kinetic energy you will get, that is equal to the work done. Another question. A particle experiences a variable force, that is 4x I cap plus 3y j cap, in horizontal xy plane. Assume distances in meters and force is in Newton. If the particle moves from 1, 2 to 2, 3 in xy plane, then the kinetic energy changes by how much is the change in kinetic energy? Means we need to find the work done. This is the variable force. I need to do the same exercise. Okay, how? I can do f dot dr. Dr I will write as dx I cap plus dy j cap. From there I will get the expression. So this is 4x I cap plus 3y square j cap dot with dx I cap, this is my dr, okay, dy j cap. We did such question previously. So what it will become from here? 4x dx plus 3y square dy, limits x goes from 1 to 2, y goes from 2 to 3. So this will become 4x square by 2, it means 2x square plus 3y cube by 3, so that is y cube, and limits 1 to 2, this is 2 to 3. Okay, now what it will become from here? Limit is 1 to 2, so this will become 2 square minus 1 square, that is 4 minus 1 is 3, 3 into 2 is 6, plus 3 cube is 27 minus 2 cube is 8, so 19, so this is 25, yeah, yes, 25 joules. I hope you are solving these questions with me. You have a notebook in your hand and you are writing the equations with me and solving these questions with me, because such type of questions are going to be asked in 2026. So make sure you are having parallel practice. Now, just by looking at the video and seeing me solving the problems, you will have like concepts will be clear, but you will not get that confidence. When you will yourself will write these equations, you may get doubt, okay, how we need to write dr there, you may get doubt, okay. So therefore I am saying that when you are seeing me solving, make sure you have a notebook and a pen, solve these questions, having some doubts, or you got the answer, put it in the comment section, okay. Another okay, let us move further. We did many questions. Now let us talk about conservative forces. So there are two types of forces, conservative forces and non-conservative forces. Conservative forces are type of forces whose work done is independent of the path followed. It only depends on the initial and the final position. Let us take, you are moving a particle from position 1 to position 2. So doesn't matter which path you followed, either you followed from the direct path or you took some indirect path or maybe some any other random path, like that. Let us take here, my work done is W2, here my work done is W1, here my work done is W3. If I say for conservative forces, and let us write for non-conservative forces. For non-conservative forces. So for conservative forces, all the work done, W1 is equals to W2 is equals to W3. And for non-conservative forces, they are not equal. Here, the work done is independent of the path followed. Independent of path followed. Okay, here it is dependent on path. Conservative forces are non-dissipative in nature. It means if they are, let us take, doing some negative work, the energy is not dissipated. Where that negative work is stored? Negative work is stored as potential energy. In conservative forces, the negative work is stored as the potential energy. Example, I am throwing a ball vertically like this. The ball is moving upward, slowing down, okay, till here. Now work done by gravity is positive or negative? Gravity is in the downward direction, motion is in the upward direction, work done by gravity is negative. Where that negative work is? That is stored in the potential energy. If you release the ball back from the top, it will come back, that it is again getting that energy back. It means that energy was stored somewhere. that energy was hidden. We say that is my potential energy, that hidden energy. Okay, that negative work was stored as the hidden energy, the potential energy. When I released it, I gained it back. Getting it? So any type of, you can say, conservative force, whether that is electrostatic or gravitation, they are non-dissipative in nature. Non-conservative forces example is friction, dissipative in nature, depends on the path followed. If you are moving, let us take from one point to another point. If you move straight, work done by the friction will be lesser, path length is less. If you move, take some curve, bigger curve, work done by the friction will be greater in magnitude. Okay, that will be greater in magnitude. Why so? Because there the path length was greater. Let us take friction was kinetic. Okay, anyway, when it is moving, the friction is kinetic. That is kinetic friction force is mu mg. Okay, so the length will increase, the work done by the friction will increase in magnitude. So it depends on the path followed, not only the initial and the final point. Now by gravity, whether let us take you move a point from here to here, or you move it like this, or you move in some another way, it will, the work done only depends upon the initial and the final position. Getting it? So I'll say that these conservative forces are non-dissipative in nature. Non-conservative forces are dissipative in nature. They'll do some work. When these non-conservative forces do some negative work, that energy is lost. Okay, the concept of potential energy, as I already discussed, the negative of the work done by the conservative forces is stored as the potential energy. It means if I say the work done, the negative of the work done as minus of du, so that is minus of f dot dr dw. Okay, so minus of this is stored as the potential energy du. So if I need to write the potential energy, if I integrate from here, from initial position, let us take r1 to final position r2, initial potential energy u1, final potential energy u2. So u2 minus u1, that is my change in potential energy, is equals to negative of the work done by this force. Okay, and if you try to relate f and du, so you can say f is equals to minus du by dr. This is the relation between the potential energy and the force. Potential energy and the force. Okay, and we discussed that negative of the work done, this w is work done by the, this is work done by the conservative force. Okay, if you are not able to understand what I am writing, visualize from the example. I am throwing a ball vertically upward, work done by the gravity is negative. Where that work done is stored, that work done, the negative of that work done is stored in the potential energy. Here kinetic energy decreases. Why so? Gravity is doing negative work. Therefore, where that energy went? Stored in the potential energy. So potential energy is negative of the work done by the conservative force. Okay, therefore I am writing here F is my conservative force. And if I let us take the potential energy is given as a function of x, y and z. Okay, all these coordinates. So you may write f as minus del u by del xi cap. Okay, partial differentiation of potential energy with respect to x, considering y and z to be constant, plus minus del u by del y j cap minus del u by del z k cap. So this is how you can find the force in I cap j cap. This minus, if let us take the force is only acting in one direction, then you can just write minus del u by del x or du by dx. Okay, but if let us take force as in along x, I cap, j cap, k cap, then you can differentiate it like this. Here del represents the partial differentiation, d represents differentiation, del represents partial differentiation. Partial differentiation of u with respect to x, when you differentiate, consider y and z variables to be constant. When you differentiate with respect to y, consider x and z to be constant. When you differentiate with respect to z, consider x and y to be constant. This is how you can find the expression of the force. Okay. Yeah. So we discussed the potential energy, that is my U, or I'll say the change in potential energy as minus of work done by the conservative force, and we related the force as well I cap minus del u by del y j cap minus del u by del z k cap. Now, when F is 0, force is 0, can the force be 0? Yes, force can be 0. Let us take the potential energy is constant. Force will be 0. Okay. So, when force is 0, it means what condition? Equilibrium. We know that is a equilibrium condition. So, when if I say my force is 0, so we call that as equilibrium condition. And there are two types of equilibrium. One stable, another unstable. Stable equilibrium means you slightly displace the particle from its position, it will come back there. Slightly displace, it will come back there. That is the meaning of stable equilibrium. Unstable equilibrium means you slightly displace, it will move. There it was in equilibrium, but you slightly displace, it will move. Let me give you an example. Let us take, it's a shape like this. A particle is here. Slightly displace, it will come back. Here you displace, it will come back, isn't it? Therefore, we say stable equilibrium. And here let us take a particle is here on top of a hill, let us take. Here you will say it is at equilibrium or not. Yes, equilibrium is there, but you slightly displace it, it will move. It will leave its position, it will not come back. Therefore, we say that is unstable equilibrium. So, stable equilibrium is the position where the potential energy is minimum. Here, the potential energy is minimum. Unstable equilibrium is the position where potential energy is maximum. Force is 0 in both the cases. Force is 0, it means du by dr is equals to 0. Du by dr is 0 when the potential energy is maximum or at minimum. Here, let us take in this. Okay. So, du by dr is 0 here also and here also. This is 0. Okay, here also it is 0. But here the potential energy is maximum. This is unstable. Here the potential energy is minimum. This is stable. Potential energy is maximum. If you see this, my potential energy versus you can say the position curve. Okay, so it is a downward parabola. Downward parabola, and here we are having an upward parabola. Upward parabola means d square u by dr square is greater than 0, okay, at that particular position, and d square u by d r I'm saying we may take x also for one dimensional motion. Okay, so d square r by dr square is my less than 0. Potential energy is maximum. It means du by dr is 0. We know that. Now for maximum condition, again differentiate. We discussed that how to find the maxima and minima of a function. Okay, when you find the maxima of the function, you again differentiate that. If that is negative at that particular point, the second differentiation is negative at that particular point where du by dr was 0, the first differentiation was 0. If that is negative, it means, okay, wait a minute, here this is positive, yeah, okay, yeah. So when it is positive, it is upward parabola. When it is negative, it is downward parabola. Du by dr is here negative, means if you see here initially my du by d square, not du by dr, I by mistakes mentioned, d square u by dr square is negative. Okay, here du by dr was positive, then 0, then negative. It means it is decreasing. Therefore d square u by dr square is less than 0, decreasing. Here it is negative, then 0, then positive. It means it is increasing. Increasing means d square u by dr square is greater than 0. Okay. So we say here, this is my unstable equilibrium, this is my stable equilibrium. Now what if another equilibrium can be neutral equilibrium, where d square u by dr square is also 0. Okay, so that is my neutral equilibrium, like a particle is placed on a flat surface, that is neutral equilibrium. We can write that also here. Another type, neutral equilibrium. So let us take potential energy position curve is given to you. There it is asking find the equilibrium position. So what you will do, du by dx or du by dr is equals to 0. Okay, then he is asking whether that position is stable equilibrium or unstable equilibrium. Then you need to check. What you need to check? You will again differentiate that. Then you will do d square u by dr square. If that is less than 0, it is unstable. If that is greater than 0, it is stable. Greater than 0 means it is a minima of the potential energy. Less than 0, it means it's a maxima of the potential energy. Where the potential energy is maximum, particle will be in unstable equilibrium. Where the potential energy is minimum, it will be in stable equilibrium. Always you can say the particle try to move in a direction where the stability increases. Stability will increase where the energy will be minimum. So energy here, potential energy. Okay, so if you release a particle, it will have its natural tendency to move in a direction where its potential energy will decrease. I am having this pen, if I leave it, it is moving down. Why so? Potential energy is decreasing in the downward direction. Potential energy is decreasing in the downward direction, therefore it is moving in the downward direction. Two charged particles are there. Let us take, both are positive. You leave them, they will move away. Why so? Because when they move away, the potential energy is decreasing. K, Q1, Q2 by R. Q1, Q2 positive, R is increasing, potential energy is increasing. Two charged particle, one positive, one negative, leave it, they will move towards. Why so? Minus k q1, because there is a negative sign of, because one is positive, another is negative, minus sign will come. R will decrease, potential energy will decrease because negative sign is there. Okay, so they will come to close, they will try to come close, the potential energy is decreasing. I hope you understood all these things. I didn't wrote like things much in like definitions and all, but I'm telling them verbally to make you understand in an easier way. Now let us read this question. The potential energy function of a particle in a region of space is given like this. Now x, y, z are in meters. The magnification of the magnitude of x component of force acting on the particle is. So he is only asking Fx. So what is Fx? Minus del u by del x. This is my Fx. So just differentiate, partial differentiate it. What is u? U is 2x square plus 3y square plus 2z. Now, when I am partially differentiating it, y and z are constant. Differentiation of constant is 0. Differentiation of constant is 0. Only 2x square term will be there. When I differentiate it, it will become 4x. So minus of 4x here. What is x then? He is asking at point 1, 2, 3. X is 1 here. So put x is equals to 1. So this will become minus 4 Newton. Minus 4 Newton. And he is asking just the magnitude. So C is correct. Minus 4 Newton means along negative x-axis. Fx is minus 4 means along negative x-axis. Okay, another question. The potential energy U of a diatomic molecule is a function dependent on R as U like this, okay, where alpha, beta are positive constants. The equilibrium the equilibrium position between them is this, where A is, okay. You may say this is equilibrium position, this is R is equals to, you may say like this, okay. So here we need to find A. Okay, now we know equilibrium means del U by del R, this is equals to 0. Equilibrium means force is equals to 0, force is minus del U by del R. So I can just say del U by del R is equals to 0. What is U? That is alpha by R to the power 10 minus beta by R to the power 5 minus 3. Now, this is alpha to R to the power minus 10. Minus 10 I will take common out, okay. Minus 10 I will take out. So, R into minus 10, R to the power, I by mistake mentioned this. Again, let me repeat it. So, this is alpha R to the power 10. So, this will become R to the power minus 10. Alpha is constant. Alpha I will take out. Alpha into R to the power minus 10. When I differentiate R to the power minus 10 into R to the power minus 10 minus 1, that is R to the power minus 11. Clear? Again, beta into R to the power 5. So, I will write this as beta into R to the power minus 5. So, beta is constant, we'll take that out. So, what that will become? Minus 5 into R to the power minus 6. So, minus beta into minus 5 into R to the power minus 6. 3 is constant. When you differentiate it, it will become 0. This is 0 from here. Okay, minus sign will get cancelled. 5 into 2, okay, R to the power minus 6, I'll take common out, and this will become R to the power minus 5. So, this will become 2 alpha by R to the power 5 is equal to beta. Is it correct? Yeah. Okay. So, from here, R comes out to be 2 alpha by beta whole to the power 1 by 5. And here I can say A is equals to 1 and B is equals to 5. He is asking A, so that is 1. Now, generally here it should be mentioned. Either they should give one of the variable, they should ask another variable, or they should tell like they are co-primes or something like that. Because if you see, this is 1 by 5. 1 by 5 I can write as 2 by 10 also. I can write as 3 by 15 also. Isn't it? So, therefore, one of the variable should be given, another should be asked. Anyways, this was asked in JEE mains, so I took it. Now, conservation of mechanical energy. I discussed that when only conservative force is acting, conservative force is of nature non-dissipative nature. It means it will not dissipate energy. It will convert one form of energy to another form of energy. Kinetic energy will be converted to potential energy, but energy will not be dissipated when conservative force is acting. So, I will say that when only conservative forces are acting, the sum of mechanical energy, the sum of kinetic plus potential energy will remain the same, because one form of energy is getting converted to another form of energy. So total mechanical energy, that is, let me denote with E, total mechanical energy, that is sum of kinetic energy plus potential energy, will be constant when only conservative forces are acting. Let me write here, this is my mechanical energy, K is the kinetic energy, U is the potential energy. Okay, so when only conservative forces are acting, total mechanical energy means the sum of kinetic energy plus potential energy will remain the same, or I'll say the mechanical energy will be conserved. Only conservative forces. This is an important point. When only conservative forces are acting, total, or I'll say just directly, I'll say mechanical energy is conserved. Mechanical energy is conserved. If I am throwing a ball upward, it should come back with the same velocity when only conservative forces are acting, means here conservative only gravity. But if let us take friction due to air is also there, isn't it? It is there. Okay, some dissipation will happen. So the velocity with which it will go up, it will not come down with the same velocity. When you at the same point, it will be having a lesser velocity. Why so? Because friction did some negative work. Okay, so let us take some non-conservative forces are also there. You cannot conserve the mechanical energy. Okay, there you can write like final mechanical energy will be initial mechanical energy minus whatever magnitude of work they did, the non-conservative forces did, friction and all, how much they dissipated, you can subtract that, and you may say like this much will be the remaining, so this much will be my final mechanical energy. That way you can say, no problem. But when some non-conservative force is there, then you cannot apply initial kinetic plus initial potential is equal to final kinetic plus final potential. Okay, in this particular case I can say, so when only conservative forces, let us take spring force is there, or gravity is there, or electrostatic force is there, I can apply like, I'll say there initial kinetic plus initial potential is equals to final kinetic plus final potential. If some non-conservative force is there, then what you will say, you need to consider the work done for that also. Okay, and you will consider some work done for that, and then remaining will be there. Okay, so they will have some negative work. Okay, so negative work will come here, so that this energy will be reduced, so that will be my final energy. Okay, now coming to this question, let us read it out. Given below is the plot of a potential energy function ux for a system in which a particle is in one-dimensional motion when a conservative force acts on it. Suppose the mechanical energy is given as 8 joules. The incorrect statement for this system is, okay, these are the statements. Kinetic energy at x3, that is 4 joules. Okay, so at x3, x3 means here at this point, here only conservative force is there. Okay, total mechanical energy is 8, that is clear to us. Yes, kinetic energy at this point, how much is that? The potential energy is 4, So potential is 4, U plus K is E, okay, kinetic is my 8, total is 8, kinetic we need to find, potential is given as 6, potential is 4, okay, potential is 4, so from there I can say kinetic is 4 here. So this is correct or not? This is correct. We need to find incorrect. Second, at x is greater than 4, the kinetic energy is constant throughout the region. Let us see x greater than 4, x greater than x4 here, in this region. Potential energy is constant? Yes. So kinetic energy will also remain constant? Yes, that is correct. So I will say this is also correct. Okay. Statement 3. X less than x3, kinetic energy is smallest and the particle is moving at slowest speed. X less than x1. So x less than x1, this is my x1, means this region. In this region, what is the potential energy? 8. How much was the total mechanical energy? 8. Kinetic energy is 0. If kinetic energy is 0, the particle is moving or not? Not moving, na? Velocity is 0. Yes, it is not moving. Not moving. It means this is incorrect, okay? This was correct, this is incorrect. The particle is not moving. At x is equals to x2, kinetic energy is greatest and the particle is moving with at fastest speed. X is equals to x2. X is equals to x2 means at this point. At this point, potential energy is 0. Potential energy is 0, kinetic energy will be equal to the total mechanical energy, that is 8, and it is moving with the fastest speed here. Okay, so the first statement is also correct. So we got third as the incorrect and it was asking incorrect. So C is the correct answer. Total sum is constant. One graph is given to you. At any point if we ask you kinetic energy, just subtract the potential energy from there. Okay, at that point you will get the kinetic energy there. Now gravitational potential energy. So potential energy relation du is equals to minus f dot dr. Potential energy, gravitational potential energy we are talking about at a certain height. Okay, so let us take from ground you are taking a particle, okay, to a height h here. Here I am considering my potential energy to be u1, here I am considering the potential energy to be u2. The displacement is in the upward direction, force is always in the downward direction, that is mg. Okay, this is a dot product. So how we will write this? F is in the downward direction, displacement is in the upward direction, F is constant, dot product when you will take cos 180, minus sign will come. So minus mg into, let us take my, here I can consider I am moving along y axis, so dy. This is my du. Integration. Initial potential energy I am considering here as u1, final at that point as u2. So I will write this as u2 minus u1 is equals to, what is this? Minus minus plus, mg is constant, integration dy is y, y goes from, this is my 0 to height h. Okay, so 0 to h. So what is that? This is h minus 0. So this becomes mgh. This is my u2 minus u1. You may say, sir, but we got only the difference in the potential energy. How to find the potential energy at a point? So it is always like that whenever we have to find potential energy at a point, we need to take a reference. We did this thing in electrostatics also. If you want to find potential energy at height h, you need a reference where we need to consider the potential energy to be 0. So here I am considering this as my reference. This was my ground. So I am considering the ground to be my reference. So I consider my u1 to be 0. So if you consider u1 to be 0, I got potential energy at any height as mgh. Is it compulsory to consider ground as reference? No. In some questions it is easy to consider some other point as reference, okay, to save some calculations. Anyways, ground you can consider reference, or any other height you can consider reference if a question is there, but one reference you have to consider. Like this is my reference. If you consider a reference level, above that reference potential energy, let us say I am moving up, mgh. What if I move down? Minus mgh. Okay, let us do this question. 0.4 kg mass takes 8 seconds to reach ground when dropped from a certain height p above surface of earth. Okay, the loss of potential energy in the last second to fall is, how much is the loss in the potential energy? So if I know h, if I know how much it fell in the last second, so I'll say loss in the potential energy is just mgh. Magnitude only he need, mgh. So how much is that? H. 8 seconds it took to fall completely. Let us take from certain height it was falling, and to reach ground it took 8 seconds. Now in last second how much it will travel? I'll say till here. I'll see how much it traveled in 7 seconds. So 8 seconds it will travel half g into 8 square. In 7 it will travel half g into 7 square. The difference of that it will travel in the last second, this much. So this will become half g into 8 square minus 7 square. I'll put it here, we'll get the answer. Let us write it, how much it is. G we are taking as 10, okay, so this is 5 into 8, 8 square minus 7 square, 8 plus 7 into 8 minus 7, that will become 15 into 1, 75 meters. Got it? Put it here. What is m? M is 0.4, G is 10, H is 75. So this will become 75 into 4, that is 300. 300 joules. This much energy, this much potential energy will decrease in the last second. Getting it? I hope you are able to understand this concept clearly, potential energy, because generally this potential energy part, specifically the definition part, is very confusing for the students. Therefore, I took many examples to explain that. Now, spring potential energy. We discussed about gravitational potential energy. Now we are talking about spring potential energy. In our the electric potential, there we discussed about the electrostatic potential energy. Now, spring potential energy, spring is there. Okay, let us draw a box like this. Kept on a surface. Initially, there was no compression or elongation. Now, what I am doing, I elongated it till here. Let us take. So, what will happen? Spring did some work, positive or negative? Spring did some negative work. Why so? Displacement is towards the right. Spring force is always towards the left, although that is variable. Spring did a negative work. Now, from here, I leave it. When it will come back, it will be having some velocity here. From where it came, spring had some potential energy here. Okay. When it was elongated, there was some potential energy that was stored in the spring, and when I left it, that potential energy was converted to the kinetic energy. Okay. So let us take, I am applying a force F to move it slowly from here, slowly. Okay, I am moving it slowly from that position till this position. Let us take, very slowly I am moving. In between, you may consider it somewhat here. I am applying some force F towards the right to move it. Spring will be applying some force Let us take this elongation is x, kx in this direction. Now if I ask you how much work done by the spring, so you will say work done by the spring force, spring. How much? Spring force is kx, dx, dot dx you need to do, kx is towards the left, dx is towards the right, negative sign will come. Elongation was, let us take from 0, initial elongation 0 to some elongation x naught. Okay, so what it will become? Minus half k x naught square, or some initial elongation was x1, final was x2, you may write this as x2 square minus x1 square. Okay, minus sign is coming. Work done by the spring is negative. I discussed that the potential energy or the change in the potential energy is equals to minus of work done by the spring. Work done is this, put it here, it will become plus half k x naught square. Potential energy final minus initial. At zero elongation or compression, I am considering the potential energy to be 0. Okay, when x is 0, potential energy is 0. That I took as reference. So I will say the potential energy U at any elongation x comes out to be half kx square. This formula you already know. So when elongation is x, the potential energy is half kx square. If work done by the spring is asked, negative of this, negative of change in the potential energy. Okay, so work done by the spring force is negative of the change of the potential energy. Make sure you are clear with this point. I am again and again repeating the same thing, like potential energy is equals to, change in potential energy is equals to negative of the work done by the conservative force. Here conservative force is my spring force. Okay, this was my external force. When I was pulling it, this was my external force to pull it. But spring force was in this direction, therefore a negative sign came, therefore work done was minus half kx square. Okay, so potential energy becomes half kx square. When elongation is 0, potential energy is 0. If elongation changes from x1 to x2, potential energy will change from, let us say u1 to u2, you can write u1 and u2 as half kx1 square, u2 as half kx2 square. Let us take, if I am pulling it till here and leaving it, and I ask you what will be the velocity when it will come back to its original position. You apply conservation of mechanical energy, you will say initial kinetic plus potential here initially is equal to final kinetic plus potential there. You will get the kinetic energy there, from there you will get the velocity. We will come to such questions also. Okay, so I hope you got this point. Now discuss this question. A block is simply released from top of an inclined plane as shown in figure. The maximum compression in the spring when the block hits the spring is. Now block will come down like this, go and compress this spring. Initially spring was not having any potential energy. When maximum, he is asking maximum compression. When compression will be maximum, block will stop. Okay. Yes, block will stop, at that instant compression will be maximum. So when this block will come here, let us take some compression is there, okay, and here I will say that the block stops, velocity is 0. There I will say the compression is, let us take x. But one more thing is there, here friction is also there. Initial some kinetic and here some potential energy was there. That potential energy, when it will come down here, convert to the kinetic energy. Now it is having kinetic energy. When it will move on the friction, the kinetic energy will decrease, because that will do some negative work. The kinetic energy will decrease slow. When it will move, when it will compress this spring, what will happen? Kinetic energy will further decrease, but that kinetic energy is stored in the form of potential energy. So if I talk about this initial position and this final position, I will say that the initial kinetic plus initial potential, is it equal to final kinetic and final potential or not? No, there is work done by spring also, work done by friction also. not spring. Spring work done is considered in the potential energy. Work done by friction also. So we need to consider here work done by this friction force. That will be negative. Initial kinetic is 0. Initial potential, considering ground as a reference, mgh, mg, what is h? H is this height. This is 10 sine 30, 5 meter. Work done by friction, how much distance it is covering on the friction? 2 meter. How much was the friction force? Friction force is mu mg. Mu was 0.5 mg. What is m, by the way? 5 kg. Okay, so 0.5 into 50, or you may write in terms of mg only, because few of the things I'll cancel. 0.5 mg. How much is the work done by the friction force? F dot S. Displacement is towards the right, friction is towards the left, sign will be negative, minus friction force into the displacement, that is 2. Displacement, that is 2. So this becomes minus mg. So minus mg, this is equals to, when it stops here, final kinetic energy is 0. Final potential energy, only spring potential energy is there. I am considering compression to be x, so half kx square. Maximum compression is x, so half kx square. Now solve from here, this will become 4 mg, so and that is half kx square. So x comes out to be 8 mg by k, root of that. 8 mg by k. What is mg? M was what is 5? Yeah. So mg is 50. What is k? Spring constant is that given to us? K is given to us. I think that is missing. The block is released from the top of the inclined plane as shown in the figure. The maximum compression in the spring when the block hits. Okay, K is 100. Sorry. Here it is given. K is 100. Let us write this 100. Okay. 50 into 2, 2 into 4. Root 4 comes out to be 2. So I will say it is 2 meters. 2 meters. It appears to be a lengthy question, but it is not that much lengthy. It's just straightforward, provided you understand that subtract the work done, or you'll say sign is there. Okay, so just consider the work done by the friction, okay, from the initial mechanical energy minus the work done by the friction plus work done by the friction, so negative sign is there, so it will automatically get subtracted. So that much will be my final kinetic plus final potential. From there you can find the maximum kinetic, maximum elongation, maximum compression, not elongation, because final kinetic is 0. Okay, another question. Now this is here, just you need to consider the potential, gravitational potential energy at A and B, and what it is asking the value of x. The speed of the particle at B is x meter per second. Then what you need to tell? You need to tell the value of x. Okay, so just solve it, pause this video and then come back. I hope you are back. Okay, so initial, this is my position 1, this is my position 2. So I will say the initial kinetic plus initial potential is equals to final kinetic plus final potential, UF I can write. Okay, initial kinetic is when the particle is slightly displacement, initial kinetic was 0. Now initial potential, if you write, you may take this as a reference, mg into 10, and this will become mg into 5. K final half mv square plus 5 mg. You could have considered this also as a reference. So final will become 0 and initial will be just 5 mg. Any of the reference you can consider, okay, whichever is convenient for you. So half mv square, this is equals to 5 mg. m got cancelled, v is root of 10g. What is g? G is 10, so v comes out to be 10 meter per second. 10 meter per second, x comes out to be 10. Now let us talk about power. What is power basically? How power is defined? So power, we say it is rate of work done. Power by a force is rate of work done by that force. If I say average power, so I will say delta W by delta T. Average power, if I talk about, that is delta W by delta T. Or if I talk about instantaneous power, or just writing that as P, so this I say as dW by dt. What is dW? dW is F dot dr. F dot dr by dt. What is dr by dt? Rate of change of position is velocity. F dot v. So we got power as F dot v. Power is a scalar quantity. Velocity is vector, force is vector. And you may write this as Fv cos theta. What is the unit of power? You may say unit of work done is joule, unit of time is second, joule per second, that is watt. That is same as watt, W. If you need to write the dimensions for this, it is mL2T minus 2, this is for joule, and here you will say T, so what it will become? mL2T minus 3. This is the dimensions for power. These dimensions are asked. Okay, dimension of power is which of the following options is correct? This may be asked. Therefore, I am saying. So, power, if instantaneous power we need to find F dot V. Whatever is the force at that instant, take dot product with the velocity, that will become the instantaneous power. If he is asking find the power in this duration, if a duration is given, let us take 1 minute or 2 minutes or some seconds like that, then you need to consider the work done, how much work is done in that duration divided by delta T. Coming to the question part. A body of mass 2 kg begins to move under action of a time dependent force given by this. This is my time dependent force. The power developed by the force at time t is. Okay, how to find that? Take dot product with v. How to find v? Mass is given, force is given, find acceleration, integrate acceleration with respect to time to find the velocity. So let us do that. If I write A is force divided by mass. What is force? 60 I cap plus 60 square j cap divided by, what is mass? Mass is 2. So divide by 2. This will become 3t I cap plus 3t square j cap. Okay, this I got as acceleration. But I need velocity. We need to find F dot V. So what is velocity? Velocity is integration of A dot dt. Like, not directly I can say this. A is equals to dV by dt. So dV is equals to integration of dV is like this. So V2 minus V1, initial velocity V1 to final velocity. Let us take my V. This is V initial and time goes from 0 to t. What is initial velocity? Begins to move under the action. Begins to move under the action. It tells you it is beginning to move, means initially it was at rest. So V minus 0 is equals to A is 3t I cap plus 3t square j cap integration of this dt from 0 to t, and what it is? 3t square by 2 I cap plus 3t square by 3, that will become 3t cube by 3, that will become just t cube j cap. This becomes my velocity, final velocity. No, not final velocity, velocity at an instant t. Now I need power at an instant, F dot V. What is F? That is my F. Take dot product with this. So let us write it, F dot V. Okay, what is F? F is 60 I cap plus 60 square j cap dot with this. This is 3 by 2 t square I cap, 3 by 2 t square I cap plus t cube j cap plus t cube j cap. Dot product, multiply this with this. So this will become 3 by 2 into 6, that is 3 into 3, 9. So 9 t cube I cap, not I cap, sorry, 9 t cube plus 6 into this. So this will become 6 t to the power 5. 9 t cube plus 6 t to the power 5. D option. Everything is fine? Yeah. Okay. Because force was given, we have to get power. So F dot V, we need to do, from F we can find V. Is that clear? Okay. Move ahead. Another question. A body is at rest, is moved along a horizontal straight line by a machine delivering a constant power. The distance moved by the body in time t is proportional to. Now this type of question, or I'll say this question is multiple times asked. Okay, some like power is constant, what will be the relation with t, or some variations in this. So let us discuss what it is. Now power is constant, that constant power is being delivered, the distance moved by the body is proportional to. How to find that? Basically I can say, let us take force is there, it will be doing some work, that work is equals to my change in kinetic energy. So how much that will be work? Power is constant, work is the total energy that is transferring. How much is that? Power into time. So power into time is the energy that is transferred, and this will become my kinetic energy. Okay, mv square. Initially starting from rest, I am considering. Yeah, it is mentioned also, starting from rest. So this will become my kinetic energy. So from there, I just need the proportionality. From there, I got that V is equal to some constant K into root of T. This K is some constant, that is my 2p by m in this case, root of 2p by m, okay, into root T. I got relation between velocity and time. I need distance and time. So V I can write as dx by dt. So dx, when you will integrate from here, so dx is k root t dt integrated. So the distance moved from here as coming out to be some constant k into t to the power 3 by 2 plus some constant, you may say. So this the position is coming like this. Okay, some constant, I am considering here this x to be displacement, so that constant will be considered here anyways. So this relation is coming. So from here I can say x comes out to be proportional to t to the power 3 by 2. That is option B, t to the power 3 by 2. There can be some other way also to do this. Okay, it's not that this is the only way. You may do with some other way also. Let us discuss another question. A 60 horsepower electric motor lifts an elevator having a maximum load capacity of 2000 kg. If the friction force on the elevator is 4000 Newton, the speed of the elevator at full load is close to. Okay, now one thing is, we need to understand that the lift is, if I take the lift is like this, motor will be applying force in this direction, mg is acting in this direction, that is force due to weight, and another friction force is also there in this direction. Okay, when it is moving, we consider that the lift is moving almost with a zero acceleration, with a constant speed. So we'll say this force that is due to the lift, that is my mg plus the friction force. Okay, mg plus my friction force, and it is moving with some velocity. Let us take v. If I find power, so power is F dot V, and in this case I can say that is just F into V. What is F? F is my mg plus my friction force into velocity, and this is my 60 horsepower. This power is given as 60 horsepower. I need to convert that to SI units. The relation is given to us. 1 horsepower is 746 watt. So 60 into 746. What we need to find? The speed, means we need to find V. What is mg? Mg is 20,000 because 2000 is mass. Mg is 20,000 and friction force is 4,000. Now here put the values, solve it, put your answer in the comment section. Take a minute, pause this video, do the calculations, then come back. Okay, I hope you did. Put your answer in the comment section. I'm not doing the calculation here. Now I am moving to the next part of this topic, that is vertical circular motion. Vertical circular motion means a particle is moving in a circular motion in vertical plane. Okay, we consider, let us take the particle is connected with a string. Okay, let me take that as dotted one. A particle is connected with a string like this. I'm giving, let us take the string is taught here. Now I'm giving some velocity initial, let us take u, and due to which it is moving in vertical circle like this. Okay, it is moving in a circle like this. Now here what is happening? Initially I gave some kinetic energy. As it is moving up, it will be slowing down. Why so? Because kinetic energy will be storing in the potential energy, isn't it? Kinetic energy will be decreasing, potential energy will be increasing, particle will be slowing down. If the particle comes at rest here, it will move back. It will not go further. Move still here, let us take, okay, the velocity may become 0 here, it will move back. Okay, velocity may become 0 in between. There may be some condition for it to complete the circular motion. Okay, when it just completes the circular motion, yes, there may be some condition. First of all, let us do some fundamental things. Let us take, this is my angle theta, the particle reaches here at this particular angle, and then I am asking, find what is the velocity here. I am asking you this basic question. It came till here, it is having some velocity v, tell me what is the velocity v there. So what you will do, you will say we will apply conservation of mechanical energy, initial kinetic plus potential is equals to final kinetic plus potential. There we can get, okay, yes, that is correct. I need to find the difference in height, therefore I am drawing it. Let us take length of the string to be L. So this will be L cos theta. Okay, and this is L into 1 minus cos theta. Now I am considering this as my initial position, this as my final position. So I will say my kinetic initial plus my potential energy initial is equals to my kinetic final plus my potential energy final. What is initial kinetic energy? Half mu square. I give velocity u there. What is initial potential energy? I am considering this as my reference, so this is 0. Kinetic final half mv square plus potential final mg into this height. Okay, this is my reference, so I need to consider height from there. Mg into L 1 minus cos theta. So plus mgl into 1 minus cos theta. Okay, so from there, if I write u, that will come out to be, not, I need to write v, sorry, the final velocity v, that will come out to be u square minus 2gl into 1 minus cos theta whole root. This becomes my velocity at a particular angle theta. I may ask what is the tension force there, or if I ask you what is the initial tension, let us find. Okay, let us do that exercise also. Different things can be asked, so I'm writing it like that. So what is the tension here? Let us take this tension as my T1. What is T1? So at this condition, if you see, downward mg, upward tension is there, and it is having a centripetal acceleration in the upward direction. So I will say T1 minus mg is equals to mass m into the centripetal acceleration u square by L. This becomes my equation. Okay, from here I can say T1 is equals to mg plus mu square by L. Okay, and as it moves upward, the tension will decrease actually. Okay, the tension will be maximum at this position. Why so? The velocity is maximum at that particular position. Okay, and gravity is also acting directly in the opposite direction. Now let us take, if I ask you what is the tension at this particular condition, so let us take here my tension is T2, that is acting in this direction T2. So mg is acting in the downward direction there, mg is in the downward direction mg. If I take the component of mg, this is mg cos theta. So here say T2 minus mg cos theta is equal to mass into centripetal acceleration in this direction. So T2, this was cos theta, okay. So for T2 I am writing, so I will say T2 minus mg cos theta is equals to m into v square by L. And I can put v there, I can find T2. Into v square is this, u square minus 2gl into 1 minus cos theta. Don't remember this equation. You may say, sir, this equation is very complicated. Don't remember this equation. Need not remember. I am just writing this equation to make you understand the concept. Okay, how you can relate the tension, how you can find the velocity at a particular angle. All these things I am making so that you, I am writing all these things here so that you understand the concepts. Not that you just try to write these equations on a paper and try to memorize. No, that is not required. I will tell you what you need to memorize. Okay. Now, let us discuss what is the condition for the particle to complete the vertical circle. Initially, it was here. I gave a velocity here u, and the thing is, I am asking you find u minimum to complete the vertical circular motion, to complete the vertical circle. I'm asking you, find u, or the minimum value of u. Now you may say, sir, it have to just complete the circular motion. What we will do? We will consider this initial and this final. When it reaches the final position there, just consider the final velocity to be 0 for initial to be minimum, and there we can find what is u minimum. But I'll say that is incorrect. What happens in case of string? This is a string. If you are moving that particle with that particular velocity, in between only the string will slack. So for string, the constraint is the string should not slack. The string should not slack means the tension in the string should not become 0. then only it will be able to complete the circle. Okay, that is the condition, not u is equals to 0 at that. No, that is not the condition for string, because the string will slack in between somewhat here only. So when it will reach at this particular point, the tension force should not be equal to 0. If the string is tight at that particular point, I will say it will be able to complete the vertical circle. Okay, that is the condition. So for u minimum, I am considering that the string just become slack. The tension just become 0. The tension just becomes 0 for u minimum. Okay. Now tension just becomes 0 means what? It will be having some velocity. Let us take v in this direction. Mg force is acting in the downward direction. Tension force is in the downward direction, and it is having a centripetal acceleration in the downward direction at this point. So I will say that mg plus tension force is equals to my mv square by L. And for u minimum, I consider this to be just 0. So from here, I got v as root of GL. So I got velocity here, v, and this is root of GL. You see, this is coming out to be non-zero for condition to complete the vertical circle. So it is non-zero. Now, this is my initial position 1, this is my final position 2. Apply conservation of mechanical energy. I will say kinetic energy at 1 plus potential energy at 1 is equals to my kinetic energy at 2 plus potential energy at 2. What is kinetic at 1? Half mu square. What is the potential? I am considering this as my reference. So 0 is equals to kinetic at 0.2 half mv square. What is v? Root of GL. So root GL square is GL. Plus what is potential? This total height will become twice of the radius, twice of length of the string. L is length of the string. So total height is 2L. So 2 mgl. Total height is 2L. Therefore 2 mgl. H is 2L. Getting it? From here, what will be u? U comes out to be, u square comes out to be 4gl plus gl. That is 5gl. So my u comes out to be root of 5gl. Root of 5gl. This you need to remember. The minimum velocity required for the particle to just complete the vertical circle is root 5gl. This is asked multiple times in mains. Make sure you remember this answer. Root 5gl. Minimum velocity at this point to just complete the circle. If I ask you find minimum velocity to just reach at this point, here let us take, what things will change? Till here, when it will reach, okay, so it is just reaching here, the speed here will become 0, the velocity here will become 0, okay, velocity will become 0 and the tension also will become 0 at this particular point, both are becoming 0, okay. So this is my case 2, that find minimum velocity here, it just reaches this point. Let us take, this is point B, this is A. U minimum to reach B. So just kinetic initial, potential initial 0, I am taking this as reference, is equals to kinetic final. It reached just with the velocity 0 there, okay, plus the potential final mgl. So what it will be? U is equals to root of 2gl. In the previous case, if I ask you, it is thrown with a velocity such that it just complete the vertical circle, that is root 5gl. When it was in between, tell me the velocity at this point. When it was at this point, now tell me the velocity. It is thrown with the velocity root 5gl. Tell me the velocity here. Put your answer in the comments. Okay. Put your answer in the comments, and that comes out to be root 3gl. So taking initial to be root 5 GL, conserve initial and final total mechanical energy, you will get at that particular point as root 3 GL to be velocity. Okay. So we have a question here. Let us read it out. A pendulum of length 2 meter consists of a wooden bob of mass 50 grams. A bullet of mass 75 gram is fired towards the stationary bob with speed v. The bullet emerges out of the bob with velocity v by 3 and the bob just completes the vertical circle. The value of v is. Now here we need to use the concept of conservation of momentum also. But anyways, we have discussed in laws of motion that if external force in a particular direction is 0, we can apply conservation of momentum. So here what basically what is happening is, there was a bob. Let me take a dotted line from here like this. A bob is there, initially at rest, bullet is coming with some velocity v. Finally, this was initial case. Finally, this bob got a velocity such that it just complete the vertical circle. What is that velocity? Root 5 GL. So here this bob got a velocity root 5 GL, and when the bullet moves, it is having a velocity of speed of v by 3. Here it is speed is v by 3. Okay, the value of v is. Now this is my initial condition. This is my final condition. In the horizontal direction, there is no external force. I can conserve the my momentum in the horizontal direction, just before the collision, just after the collision. So what is the initial momentum in the horizontal direction? mv. Mass of the bullet is, how much is the mass of the bullet? Wooden bob mass is 50 gram and bullet mass is 75 gram. So this is 50 gram, this is 75 gram. So initial momentum is 75. I am writing mass into mass in grams only, because anyways the units will get cancelled. So this is the initial momentum. Final momentum, final bob mass was 50 grams. Okay, so 50 into root 5 GL plus 75 into v by 3. Okay, easy. So from here what I can do, I can cancel also. So this will become 75 into 2v by 3, and this is equals to 50 into root 5 GL. Root of 5 into g is 10 into L is 2. So 5 into 10 into 2, that is 100. So 100 root is 10. So this comes out to be 500. Okay, and 25 into, I can say this is 25 into 2, this is 25 into 3. This 3 got cancelled, this 2 got cancelled. So v comes out to be 10 meter per second. 10 meter per second. Okay, here basically we need to know that the minimum velocity there which is needed for completing this vertical circle is root 5 GL. Everything else is given, just apply conservation of momentum, you'll get v. Another question. A bob of mass m is suspended by a light string of length L. It is imparted a minimum horizontal velocity at the lowest point A such that it just completes half circle reaching the topmost position B. Okay, the ratio of, here it is saying it just completes. Just complete means that ratio will be maintained here, it will be root 5 GL. Velocity will be root 5 GL here. Okay, just complete the vertical circle reaching the ratio of kinetic energy at A and B. So here we know this velocity comes out to be root GL and this velocity comes out to be root 5 GL. This we already know. Ratio of kinetic energy means ratio of the squares of the velocity. Half m anyways will get cancelled. So kinetic energy at A, that will be, this ratio will be, I'll say VA square by VB square. This comes out to be 5 GL. This is GL. So this is 5:1. 5:1. Just straightforward, simple question. This was asked in 2024. Therefore, I am saying this result, that is root 5 GL, is important to memorize. So make sure don't forget that. Another question. A block slides down from the top of hemisphere of radius r 3 meter as shown in the figure. The height at which the block will lose contact with the surface. Now, when it slides, so what will happen after some time? You know that it will lose contact with the surface and it will just become a projectile. So, at what particular angle it will lose the contact with the surface? Losing contact means the normal reaction will become zero, isn't it? So, let us take the block, comes somewhat here, where he is having some velocity v, this normal reaction here n, downward force mg, whose component in this direction will be mg cos theta, whose component in this direction is mg sin theta. Now, along the radial direction, if I write, it is having a centripetal acceleration towards the center. So, along this radial direction, if I write the equation, what I will say? I will say that mg cos theta minus n is equals to mv square by r. Mg cos theta minus n is equals to mass into centripetal acceleration mv square by r, and here the radius is mentioned as r, okay, by r. To lose the contact means normal will become 0 here. So, it loses the contact means this becomes 0. If this becomes 0, v comes out to be root of rg cos theta. I got the velocity for the condition normal reaction, normal force to be 0 there. Now, this is my initial point, this is my final point. Conserve the mechanical energy. Initial kinetic plus potential is equals to final kinetic plus potential. You can take any of the level as reference. You may consider topmost also as reference. You may consider ground also as reference. So, let us consider ground as reference. So, if I write initial, let me write initial kinetic plus initial potential is equals to final kinetic plus final potential. So, what is initial kinetic here? 0, because it is at rest. Initial potential mgr, potential energy. What is final kinetic? Half mv square. What is v? rg cos theta. V square is rg cos theta plus final potential mg into this much height. What is this height? This height. This I can say, okay, this is given as h. We need to find h. So, I will say mgh. This is clear? Cos theta, can I relate theta with r and h? Yes. You see this right angle triangle and this right angle triangle. This is theta, so this is theta. So, I can say cos theta comes out to be, this is my base, which is h, divided by hypotenuse, that is r, h by r. Okay. You put here, what else? Everything else is fine, I hope. Okay. So, let us put cos theta. M I am cancelling first. G I am cancelling. Okay. So, this becomes r equal to, this is r by 2 into h by r by 2 into cos theta is h by r, okay, and plus h here. So, this got cancelled. So, h plus h by 2, 3h by 2. So, 3h by 2 is equals to r. So, from here h becomes 2r by 3. H becomes 2r by 3. What is r? R is 3. So, r is 3, h comes out to be 2 meters. So, 2 meters. This was, I'll say, a bit not complicated, conceptual. So, here you need to understand what is the condition when normal reaction becomes 0. So, that you need to understand for this. Need not remember this answer here, just see the method, try to understand the method that is required. Okay. Now we are starting the next important portion of this chapter, that is collisions. And collisions is also, I'll say, important topic. And from collisions, very simple questions are asked. Very simple questions are asked in mains, like just straightforward things. So need not go for much complicated 2D collisions that we practice for JEE Advanced. So those type of questions are not asked. In 2D also there are few questions that means NT has asked till now, but they are very simple, not that much complicated. We will discuss that. Okay. So generally collisions means two particle colliding, we say that is a collision. So on the basis of energy loss, we define two types of collision: elastic collision, inelastic collision. Elastic collisions, we say no energy is lost. Inelastic collisions means energy is lost. And a part of inelastic collision is perfectly inelastic collision. There we say the maximum energy is lost. Okay, so that is a sub part of this. So a part of inelastic is my perfectly inelastic. Perfectly inelastic. Okay, and there I say maximum energy is lost. Two particles are colliding, momentum will be conserved. Okay, momentum will be conserved. Two particles are colliding on the system, no external force is there in that particular direction. So we will say the momentum will be conserved. And also even if there is some external force, if that is not impulsive in nature, so we can consider just before the collision and just after the collision the momentum will be conserved. Okay, so even if let us take two particles are colliding like this vertically, you may say gravity is acting there, but that is not impulsive in nature. So just before the collision in the vertical direction and just after the collision the momentum will be conserved. Okay, so momentum will be conserved, but the thing is kinetic energy may be conserved, may not be conserved. If elastic collision is there, kinetic energy will be conserved. If elastic is there, so I will say whatever is the total initial kinetic energy of both the particles is equals to my total final kinetic energy of both the particles. If inelastic collision is there, that condition will not be there. In inelastic, energy will be lost. How much it will be lost? It depends which type of collision is there. Okay, so there we define coefficient of restitution to denote how much energy is lost. That relates the energy thing. So if elastic collision is there, the coefficient of restitution is 1. If it is perfectly in elastic collision, that is 0. Both the particles moves together. I am coming to that. Coefficient of restitution. So coefficient of restitution is defined as, so let us take two particles. Okay, before and after condition I am drawing here. So let us write one condition as before condition. This is before collision. And this is after collision. Okay, so before collision, let us take they were having some velocity. This is u1, this is u2. After collision, they are having some velocity. This is v1 and this is v2. So coefficient of restitution is defined as the ratio of velocity of separation divided by velocity of approach. So E is my velocity of separation divided by velocity of approach. approach. So here if I say velocity of separation, that is v2, the velocity with which they are moving away. So v2 minus v1, okay, this is the velocity with which they are moving away, and this here velocity of approach, I will say this is u1 minus u2, okay. So this becomes my velocity of separation and velocity of approach ratio. Now for elastic condition, when the energy is conserved, coefficient of restitution comes out to be 1. So E is equals to 1 for perfectly elastic collision, or I'll just say elastic collision. And E is equals to 0 for maximum energy loss for perfectly inelastic collision. Perfectly inelastic collision. E is equals to 0 means V2 minus V1 is equals to 0, means V1 is equals to V2. They move together after the collision. Okay, particles move together after the collision. Particles move together after collision. As we can say, V1 is coming out to be V2. Okay. This is I am writing for 1D collision. Okay. Now in 2D, there we need to like define the line along which the collision is happening, then we need to take the component of the velocity, all those things. That is not required for JEE mains. I am not going into that much detail. I am just writing the things which are asked in mains. Okay, I am not going into the very details of these things which is not required for mains. Now elastic collision means energy is conserved, two particles, these are before collision, these are after collision. Initially having velocity u1, having velocity u2, it is having velocity v1, having velocity v2 finally. Okay, this is after collision condition. After, this should be after. This is before collision. Okay, now I am considering this mass to be m1, this mass to be m2, this mass m1, m2. Here we are considering head-on collision, like 1D only. Okay, head-on 1D collision we also call that as head-on collision. Okay. Now conservation of momentum, if I write the equation for conservation of momentum, let us write that. Conservation of momentum. So if I write this equation, what is the final, what is the initial momentum? That is equal to my total final momentum. What is the initial momentum? m1 u1, okay, plus m2 u2. I'm writing this as vector because we need to take the direction also. If let us take m2 is in the opposite direction, then you need to write minus sign here. Okay, if it is u2 is towards the left, you will consider minus here. Okay, this is equals to my m1 v1 final momentum, m2 v2. This is my conservation of momentum. Next is, as we discussed in elastic collision, this is a elastic collision, so conservation of energy will be there. So I can say total initial kinetic energy is equal to my total final kinetic energy. Let us write that. So conservation of energy if we need to write, how we write the initial kinetic energy, half m1 u1 square plus half m2 u2 square is equals to half m1 v1 square plus half m2 v2 square, so equal to our final kinetic energy. Now we can solve for V1, V2, but this much is not needed. This is not needed. In place of this, we'll use coefficient of restitution. We'll use E is equals to 1. What is E? V2 minus V1 divided by, what was that? Velocity of approach, U1 minus U2. U1 minus U2, and this is equal to my 1. I'll use this. Why? Because this is a quadratic. Both will give the same result. Either you use these two equations or you use these two equations. So instead of this energy equation, you can write coefficient of restitution thing. That will save your time. Okay, and then relating V1 and V2, you can put and you can solve. We'll come to such questions also. Okay, now let us discuss a condition. The condition is, example I am taking, okay, two particles. Initially, they were moving towards each other. They are having same mass m. Here it is having velocity 2 meter per second. Here it is having velocity 3 meter per second. You have to find these final velocities. We don't know in which direction it would be. Okay, let us take V1, V2. Okay, it is having some velocity in this direction V1, and it is having some velocity in this direction V2. So what is V1, V2? We need to find this. I'm just doing some exercise with you. So initial momentum, that is m into 2 plus the minus, because this is towards the left, so minus m into 3. This is total initial, total final, m into V1 plus m into V2. M got cancelled. So from here I got V1 plus V2 is equals to 2 minus 3. What is that? Minus 1. Another equation, coefficient of restitution, that is 1. That is velocity of separation, V2 minus V1 divided by velocity of approach. What is velocity of approach? 2 plus 3. With 5 they are approaching each other. So 5. So we got V2 minus V1 is equals to 5. So V2 minus V1 is equals to 5. How to solve that? Add these two. So this will become 2V1, not 2V1, 2V2. If we add them, so 2V2 is equals to 4. So from there V2 is equals to 2. Okay, and what is V1? Put V2 is equals to 2. So V1 is equals to 2 minus 5, that is minus 3. So V1 is coming out to be minus 3, means it will move in this direction with velocity 3 meter per second, and V2 comes out to be 2, it means it will move in this direction with velocity 2 meter per second. Interesting thing to note here is, if both the masses are equal, colliding elastically, when they will collide, their velocity will get interchanged. Initially this mass was having towards the right 2 meter per second. Now another M2 mass is having towards the right 2 meter per second. Initially this was having towards the left 3 meter per second. Now first mass is having towards the left 3 meter per second. Let us name them as A and B, so that there is no confusion. Okay, velocity get interchanged, or I'll say exchanged. Velocities are exchanged. Why so? Collision was elastic and masses were equal. This is the condition. So try to, I'll say this, keep this thing in mind. If two masses are equal, when they collide elastically, the velocity will get interchanged. When not equal, they will not interchange, or if collision is inelastic or some coefficient of restitution is there between 0 and 1, it will not change, not interchange. Okay. Here I mentioned that E is equals to 1 for elastic collision, E is equals to 0 for inelastic, perfectly inelastic collision. Coefficient of restitution will be between 0 and 1 for inelastic, general inelastic collision. So I'll say it is between 0 and 1 for inelastic. I took till now, I took elastic collisions. Okay, now let me take We have some example for this elastic and then we'll come to inelastic. Okay, let us have these two examples. As per the given figure, a small ball P slides down the quadrant of a circle. Okay, it slides down, hits another ball Q of mass which is initially at rest, okay, of equal mass. The mass is same, this mass is m, this is also m, this was at rest. Initially the effect of friction and neglecting the effect of friction and assume the collision to be elastic, the velocity of Q after collision will be, both masses are equal, colliding elastically, is it given or not? Elastic. It means velocities will get exchanged. P will come here, P will have some velocity. After collision, what will happen? P will come at rest, Q will have that velocity. So what I need to know? I need to know what will be the velocity of this particle P just before the collision, and that will become the velocity of Q after the collision. So what will be the velocity of P just before the collision? Here it was this this height, okay, now it is coming at sliding down to the ground level. So initial kinetic plus potential is equal to final kinetic plus potential. So initial kinetic was 0, initial potential was mg into this radius r is equals to final kinetic half mv square, final potential 0, because reference is my ground. So velocity comes out to be root of 2 gr. So what is r? R is 20 centimeter. R is 20 centimeter. Converting that to meter, this comes out to be 2 meter per second. So it is coming with velocity 2 meter per second. After collision, what will happen? P will come to the rest, Q will have a velocity of 2 meter per second. So the velocity of ball Q after the collision will be 2 meter per second. These options are in meter per second. Okay. Therefore, I discussed that concept. You keep that thing in mind. If masses are equal, if they collide elastically, their velocity get interchanged. M was there, after sliding down at height of 20 meter, root 2 gr we got the velocity to be 2 meter per second. After collision, 2 meter per second will be transferred to Q. So Q will have a velocity of 2 meter per second. This concept is interesting, isn't it? Okay. Another question on this. A body of mass 2 kg moving with a speed of 4 meter per second makes an elastic collision with another body at rest and continues to move in the original direction but with 1/4 of its initial speed. The speed of another ball after collision is, okay, mass 2 kg, okay, another mass is not given to us. So this was mass 2 kg and let us take this mass was m. This was moving with velocity 4 meter per second and this another was at rest. This is before collision condition. After collision, always draw these, okay. So whenever like you are writing the conditions, okay, so I'll say the best way is draw the conditions so that you can visualize it, and when you visualize the things, writing equations becomes very easy. Okay, I can directly also write, but when I draw, I feel like, oh, these two particles are moving towards each other with these velocities. So visualization helps us to write equations quicker and with, I'll say, zero error. So after collision, what is mentioned? I'm saying this as A, this as my B, this is A, this is my B. Okay, and continues to move in the original direction but with 1/4 of its initial speed. It moves in this direction with velocity of 1/4 of initial means 1 meter per second. Okay, the speed of another ball after the collision is, let us take this speed to be V. We need to find V. So first of all, conservation of momentum, and then I'll say conservation of energy because the collision is elastic. But what we can do is we can just write the equation for coefficient of restitution, because here I just need to find the speed. I don't need Mass. Okay. So I am using coefficient of restitution to be 1. Why? Elastic collision. Therefore, I can take 1. Velocity of separation. Separation will be v minus 1 divided by velocity of approach, that is 4. So from here, I got v as 5 meter per second. I got the velocity of other particle as 5 meter per second. I could have used used the other equation for conservation of momentum also, but that is not required here. If I use that conservation of momentum, then mass will be there. But I don't want mass. He is not asking to find mass. If he would be asking to find the mass of the other particle, then I'll be using this velocity, then write the conservation of momentum equation, put their velocity, you'll get mass from there. Now coming to inelastic collision, as we discussed, inelastic collision means maximum energy loss, and after collision both the particles, okay, this is not perfectly, by the way, yeah, perfectly inelastic means maximum energy loss. Okay, now we are we are talking about general inelastic collision, not the maximum case. Okay, that is general. I'll talk about maximum also after this. So initial condition, having velocity v1, u1, u2 I am taking, u1, this is u2, after collision this is v1 and this is v2, this is after collision. Mass is m1, m2, m1, m2. So the two conditions, conservation of momentum, okay, conservation of momentum, I'll say m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. Conservation of energy will not be there applicable because this is inelastic collision. Now here what we will use? Coefficient of restitution, that will be given to us. So coefficient of restitution is velocity of separation v2 minus v1 divided by velocity of approach, that is u1 minus u2. Now from here we will solve, we will find v1 and v2. Coefficient of restitution will be given to you in the question. Okay. Now another condition, that is perfectly inelastic collision. Let us write that with a different color. Okay. Perfectly inelastic collision. Before condition, after condition, I need to draw it properly because it would be moving together. Yeah. Yeah, now it is okay. So having velocity m1, having velocity u1, m2 having velocity u2. Now this m1 and m2 moving in this direction together with final velocity v. Okay, and let us write also that this is my before and this is my after condition. Coefficient of restitution is 1. Sorry, coefficient of restitution is 0. I already considered that. 0 means velocity of separation is 0, as I mentioned previously. Coefficient of restitution. Okay. So coefficient of restitution is 0 means v1 and v2 are same, means both are moving together. I considered that condition here. Both are moving together, I considered there. Okay. So I am writing here that m1 and m2 are moving with velocity v. So here just write the equation of conservation of momentum. So m1 u1 yeah, so m1 u1 plus m2 u2 is equals to, finally both are moving together with same velocity, and I got V directly m1 u1 plus m2 u2 divided by m1 plus m2. Both are having same velocity after the collision, and this is perfectly inelastic condition. Let me tell you, in mains hardly they will ask you about elastic collision, inelastic collision. Hardly they will ask you about inelastic collision. General, they will not give coefficient of restitution between 0 and 1 and like that. Generally 90% of the cases either they will ask for elastic collision or they will ask for perfectly inelastic collision where they will move together. Let us solve some questions. A ball is dropped from a height 20 meter. If coefficient of restitution of the collision between ball and floor is 0.5, after hitting the floor, the ball rebounds to a height of what? How much height it will go? Okay. So, ball fell from a height of 20 meter. This is 20 meter. Now, it will strike the ground with velocity how much? Root 2 gh. If it is falling from height h, velocity will be root 2 gh. How I wrote this? Either you write mgh is equals to half mv square, or you use the equation like v square minus u square is equals to 2h. From there you can write v is equals to root 2 gh. After collision, what will be the velocity? Coefficient of restitution, let us take, is E. Initial velocity was v, after collision it will become E times of v. How I wrote it? Velocity of separation velocity is final velocity v. Okay, I am writing this v as root 2 gh. Okay, so let me write another thing. This is my velocity of separation divided by velocity of approach. This is how I can write. Okay, so the variables I am not taking properly. This is u, basically I should write this. I have written v. Okay, let me change that so that you are not confused. Let me change it. Let me write this as u, the initial condition, with velocity u, and this is root of 2 gh, and finally it is moving up with velocity final, let us take that as v, and I am saying this is E times of my final velocity, my initial velocity, that is u. Okay, so E, coefficient of restitution, how I wrote this? Coefficient of restitution is my velocity of separation. Velocity of separation is v divided by velocity of approach. Velocity of approach is u. Therefore, I am saying here this velocity will become E times of u. After striking, it will become E times of u. The ground is at rest there itself. Getting it? So if I write this velocity, this is E times of root 2 gh. Now it will go to some height. Till which height it will go? How much will be this? Let us take this height as h dash. Okay, h dash. Velocity, I know how can write h dash? V square by 2g, or I can use conservation of mechanical energy also, and then that way also I can write. Okay, so if I say here h dash v square by 2g, v is E root 2gh square by 2g, so this is E square h. E square h. E is 0.5, E square is 1 by 4, okay, into h is 20, so this comes out to be 5 meters. Is this clear? So when a ball strikes, coefficient of restitution is E. After collision, the velocity will become E time. It will go to a height of E square h. Velocity becomes E times, so the height will become E square times. Another question. a large block of mass m, that is 5.99 kg, is hanging from two long massless cords. A bullet of mass 10 gram is fired into the block and gets embedded into it. The block and bullet then swing upward, okay, and rising till a vertical height of distance of 9.8 centimeter. So this, they rose like 9.8 centimeter before the block plus bullet pendulum comes momentarily to rest. The speed of the bullet just before the collision is. Now here the bullet was there. Bullet was moving, having some speed. Let us take what velocity? U. It strike. The collision is inelastic. They will move together with what velocity? Let us take this velocity V. Now they are having some kinetic energy. It will go till some height h. There it will stop. So when it stops here, here my velocity will be 0 at this condition. Here my velocity is 0. Now between this condition and between this condition, applying conservation of mechanical energy, I am taking this as a reference. So initial kinetic is equal to my final potential, because final kinetic is 0. So initial kinetic is half m plus m into v square. Both are having same velocity. Final potential, finally m plus m gh. I am considering mass of bullet to be small m and mass of plank to be capital M. Anyways, this is getting cancelled. So this velocity is root 2 gh. This is not the final answer. This is velocity after the collision, the common velocity. I need before collision velocity of the bullet. Okay. So how much is this root 2 gh? Root of 2 into what is g? G is 9.8. 9.8. What is h? H is 9.8 centimeter. So 9.8 by 100. So from there I can write this as 9.8 by 10 root 2. This is the common velocity after the collision. Now applying the concept of collision. Before collision, the momentum is m into u towards the right. Okay. After collision, both are moving with the same velocity, so both will have the same velocity, m plus m into my final velocity v. What is mass of bullet? 10 grams. This is 10 actually. 10 gram. This is 10 grams. So 10 gram means 0.01 kg. Okay, 0.01 into u is equals to 0.01 plus 5.99, that is 6. So 6 into v. So my u comes out to be 6 by 100. Sorry, yeah, not 6 by 100, that is 6 into 100. 6 by 0.01, I'll say, into v. What is v? 9.8 by 10 root 2. So this will become 6 into 98 root 2. 6 into 98 root 2, and that will come out to be about 831.5 meter per second. Getting it? Conservation of mechanical energy, when I am using that, I am using after the collision. I am not using mechanical energy conservation this condition and this condition. Why so? There is energy loss in the collision. Collision is inelastic. Therefore, I can use after this collision when it is rising till height h. There I can use conservation of mechanical energy. Another question. Read it out. 3 blocks A, B, C are lying on a smooth horizontal surface as shown in the figure. A and B have equal masses m, while equal masses m, while C has mass capital M. Okay, this is C. A and B are having equal masses m, C is having capital M. Block A is given an initial speed v towards B, due to which it collides. Okay, it is having initial speed v. It collides with B perfectly inelastically then combined mass collides with C also perfectly inelastically. If 5/6 of the initial kinetic energy is lost in the whole process, what is the value of m by m? It will collide with this m, again inelastically it will collide with this another mass m. So initial condition is this, only initially mass A was moving with velocity v towards the right. Finally, after the two collisions, all the three masses are moving with same velocity towards the right, and let us take that as my v final. Now conservation of momentum, so m into v, this is equals to m, 2m plus m. 2m plus m, this is the final mass, and into final velocity v final. So from there I got my v final to be m divided by 2m plus m into v. Getting it? I got velocities, I can write the kinetic energies. The relation is given to me as 5/6 of the initial kinetic energy is lost in the whole process. 5/6 is lost. It means if the initial kinetic energy is k here, how much it is now? K by 6. This energy is k by 6. So final energy, if I write, that is half 2m plus m into this velocity square, that is m divided by 2m plus m square into v square. The final kinetic energy is 1/6 of the initial kinetic energy of this half mv square. This is my condition. Okay, this is my condition. Now from here you solve this equation, v will get cancelled. Okay, few of the other things will also get cancelled, and then you will get the relation between small m and capital M. So I am leaving here for you to solve this, and make sure you comment your answer in the comment section after solving it. Now let us discuss about oblique or 2D collisions. Now when 2D collision is there, so what happens is, let us take some particle is, the collision is not head on, okay, like this. This is, I am saying this is my before collision condition. This is my mass m, this is my, let us take m1, and this is m2. It was having some velocity u1, and let us take some velocity u2. So after the collision, let us take they are having some velocity v1, velocity v2 like this. Okay, this is a 2D collision. Okay, not 1D. If it were 1D means particle before and after collision they are moving in the same direction. Okay, they have the velocity along x-axis only, we consider like that. But here this is my m1, this is my m2, this is after collision, this is my before collision. In such questions, what I can do, I will apply conservation of momentum along x-axis and y-axis separately. Okay, so I apply conservation of momentum. So along x-axis, so along x-axis, if I say initial momentum is m1 u1 plus m2 u2, they are having velocity horizontal only. After the collision, let us take this angle is theta, this angle is theta 1, theta 2, okay, theta 1, theta 2. So final momentum along horizontal direction will become m1 v1 cos theta 1 plus m2 v2 cos theta 2 there. I considered these velocity u1 and u2 towards the right only, so I'm just writing m1 u1 plus m2 u2. Consider them towards the right only. Okay. Now this becomes my conservation of momentum along x-axis. Along y-axis also I will apply. Along y-axis, so initial momentum along y-axis is 0 because initially both are moving only along x-axis. There can be some different condition where along y-axis initial momentum is 0. I am not writing a general equation, okay. It may happen like condition is given where there is some initial momentum along y-axis, then you need to consider that. But here it is 0, so 0. Final, it will have in the upward direction how much? m1 v1 sin theta 1, because the component of v1 along y-axis is v1 sin theta 1, and v2 along y-axis will be v2 sin theta 2, that is in the downward direction, therefore minus. So applying those conservation, and then you can solve. If the energy is conserved, you can make initial kinetic energy to be equal to your final kinetic energy. And if let us take the collision is not elastic, then the energy will not be conserved. Generally, or I'll say in mains, inelastic collision in 2D will not be asked, okay. So don't go into that much detail where coefficient of restitution is E, and then you need to take the components of the velocity to see the velocity of separation and approach like that. That is not required in mains. Therefore, we are not going into that much detail. Now, let us solve a question. Particle A of mass m1 moving with velocity this collides with another particle B of mass m2 which is at rest initially. Let v1 v2 be the velocity of the particle A and B after collision. m1 m2 relation is given, after collision v1 is given, the angle between v1 and v2 is. How to find that? I'll find v1. Okay, how to find v2? v1 is given, sorry. First I'll find v2. How to find v2? m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. There I separately wrote the equation along x-axis and y-axis. I can combine way also I can write one equation only, m1 v1 m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. I cap things and j cap things will be equated there. I'll show you. So if I write here conservation of momentum m1 into v1, what is v1? v1 is root 3 I cap plus j cap plus m2. What is m2? M2 is given as m2 only. Okay, this is at rest. Okay, so u1 u2 is 0 is equal to after collision m1 v1 is I cap plus root 3 j cap plus m2 into v2 I need to find. m2 is m1 by 2, I can put it here. m2 I can put as m1 by 2. Okay, from there I can cancel out m1, and from here if I write v2, that will become twice of root 3 minus 1 I cap and this will become 1 minus root 3 j cap. Okay, this I got v2. Perfect. Now I need angle between v1 and v2. How to find that? When I was discussing dot product, I discussed that cos theta, I know v1 dot v2 is equals to v1 v2 cos theta. Therefore, cos theta is equals to v1 dot v2 divided by magnitude of v1 into magnitude of v2. How to take dot product? You know that v1 is given, v2 is there. Okay, take the dot product, divide by the magnitude. When you solve, you will get the answer. I'm not solving it further. I'm leaving it for you from here. Okay, so do the next part of this question and make sure you comment your answer in the comment box. Another question on this: a particle of mass m is moving along x-axis with initial velocity ui cap. It collides elastically with a particle of mass 10m at rest and then moves with half its initial kinetic energy. Okay, it was having velocity u initially, kinetic energy was there, half m u square. 10m, here it is mentioned, particle 10m, this was at rest and then moves, after the collision, moves with half the initial kinetic energy, means here velocity will be u by root 2. Then only the kinetic energy will be half. Speed should be u by root 2, na? Because velocity, kinetic energy is half mv square, na? So speed will become u by root 2. Okay. And what? I need the relation between sine. Okay, sine theta 1 is equals to, this is sine theta 1. Okay, sine theta 1 is equals to root n sine theta 2. We need to find the value of n. Okay, so what we need to do, let us apply conservation of momentum along horizontal direction and vertical direction. That we can do, yes. So along horizontal direction, initial momentum is mu. Final momentum is, okay, I'll get cos theta 1 and cos theta 2, but I don't need that, so I'm not writing horizontal. Let us write vertical. Along vertical direction, initial momentum is 0, yes, 0, is equals to final momentum along vertical direction. This will become mu by root 2 sine theta 1, mu by root 2 sine theta 1, and for other particle, let us take the velocity is v here, okay, v here. So 10 mv sine theta 2 with a negative sign because that is in the downward direction. So minus 10 mv sine theta 2. So from here I got this m is getting cancelled. From here I got sine theta 1 is equals to 10 root 2 into v by u sine theta 2. Basically I need v by u. What is v by u here? I need v by u. How to find that? Apply conservation of energy, because this is elastic collision. What is the initial kinetic energy? Half mu square. What is the final kinetic energy? Half mu by root 2 square, kinetic energy of first particle plus the kinetic energy of second particle. Perfect. Kinetic energy of first particle plus the kinetic energy of second particle. Yes. M got cancelled. Half got cancelled. U square minus u square by 2 is equals to 10v square. So basically v square comes out to be u square by 20. And v by u comes out to be 1 by root 20. Put it here, 10 root 2 into 1 by root of 20 sine theta 2. So what it will become? This will become root of 10 only, isn't it? Root 2 will get cancelled, root 10 will remain in the numerator. So this will become root 10. So this is root 10 and comes out to be 10. Okay, although 2D collision question was there, but it was not that difficult. Just apply conservation of momentum along horizontal, vertical, and conservation of energy. Here we need not write the horizontal conservation of momentum equation because their cos theta will come. I don't need cos theta here. Okay, I don't need that. Therefore, I didn't write that actually equation. So even if I will be writing that equation, so cos theta will come, and then in the vertical direction sine theta relations will come, and then solving that may be easy, may not be easy. I don't know whether that will be easy or not. You can check that by writing the horizontal equation and vertical equation and then just solving horizontal and vertical to get the relation if that is possible. But I am not sure. Therefore, I wrote it like this because I need sine theta only. Another equation of relating the velocity I got from there, directly I solved it. Okay. So till here we have seen all the varieties of question in work, power, energy, different type of questions. We discussed the type of questions or the questions that are asked in JEE mains. Many of the questions were just very simple. Therefore, if you have skipped some part of this video, make sure you watch it fully, because I have in detail I have considered all the concepts with all the varieties of the questions. So make sure you watch the video completely and you comment on the comment section that you completed this video. Also, we have a handpicked set of questions for you. Make sure you don't miss. Go in the description box, click the link there. You will join our free batch. From there you can access the notes of this class and the DPPs for your practice. We'll meet in the next video. Thank you all.